Hello everyone, welcome to Unacademy GATE Telugu channel. This is Bhanu Prakash, expert in GATE and ESE. I did MTech from NIT Kurukshetra. I have 10 years of teaching experience. I can teach electrical machines and power electronics. PPC 10 is my referral code. Use this code, you will get 10% discount on Plus subscription and Iconic subscription. So by taking Plus subscription, what are the benefits and what are the benefits of the Iconic subscription? So by taking Plus subscription, you will get live classes from the top educators of the country, and also you can get structural schedule per 3 months, 6 months, 12 months and 24 months, unlimited practice questions per subject wise and topic wise. Similarly, test series per subject wise and topic wise. And the another subscription is Iconic subscription. So by taking Iconic subscription, okay, you get these four benefit. In addition to these, some other benefits also you will get. So such as a personal coach. That means we will assign a personal coach. He will guide everything until you get a job. And study planners, we will provide the proper study planners, expert guidance, ESE mains questions and answers. Okay. So per IAS point of view, this Iconic preparation is the best suitable, and BPC 10 is my referral code. Okay, use this code, you will get 10% discount on Plus subscription and Iconic subscription. Okay, and this is what is the price for the Plus and Iconic subscription? So first one is this Plus subscription is available for 12 months, 18 months and 24 months. For 12 months, the fee is at 27,225 rupees. For 18 months, the fee structure is at 34,650 rupees. For 24 months, fee is at 39,600 rupees. Okay. BPC 10 is my referral code. Use this code, you will get 10% discount on Plus subscription as well as Iconic subscription. And another subscription, Iconic subscription, is available for 12 months and 24 months. For 12 months, fee is the 45,225 rupees. For 24 months, fee is 66,600 rupees. So BPC 10 is my referral code. Use this code, you will get 10% discount on Plus subscription as well as Iconic subscription. Okay. Gayatri, good afternoon. How are you? Good afternoon. Welcome to Unacademy GATE Telugu channel. Okay, first tell me, is my voice clear or not? Is it clear now? Are you able to hear me? మీకు వినిపిస్తుందా? Yes, thank you. Okay. సో లాస్ట్ క్లాస్లో మనం ఏం డిస్కస్ చేసామంటే వాట్ ఈజ్ మీన్ బై ఆటో ట్రాన్స్ఫార్మర్. ఓకే, ఆఫ్టర్ దట్ వీ హ్యాడ్ డిస్కస్డ్ అబౌట్ వాట్ ఆర్ ద కంపారిజన్స్ బిట్వీన్ ద ఆటో ట్రాన్స్ఫార్మర్ అండ్ టూ వైండింగ్ ట్రాన్స్ఫార్మర్స్ and realization of auto transformer from the two winding transformers, that is the conversion of auto transformer from the two winding transformer. Okay, ఒకవేళ టూ వైండింగ్ ట్రాన్స్ఫార్మర్స్ మనకు ల్యాబ్ లో అవైలబుల్ ఉందనుకోండి, దాన్ని ఆటో ట్రాన్స్ఫార్మర్ గా ఎలా ఆపరేట్ చేయాలి? సో how many ways are there to operate as a auto transformer from the two winding transformer? That is we call realization of auto transformer from the two winding transformer. ఆ పార్ట్ కూడా డిస్కస్ చేసాం. ఇంకొకటి ఆటో ట్రాన్స్ఫార్మర్స్ లో వాట్ ఆర్ ద advantages of auto transformer as compared to the two winding transformer. ఇది కూడా last class లో discuss చేసాం. So I will tell you all the formulas okay we had discussed here. Always here in auto transformer, input kVA of auto transformer is equal to output kVA of auto transformer. So ఈ part కూడా మనం last class లో discuss చేసాం. So this is the first formula. And how do we get input kVA of auto transformer? Input kVA is equal to, so that is a V1 multiplied by I1, okay? And third one, output kVA of auto transformer, so it is equal to V2 multiplied by I2 here. So comparison, next one, the always input kVA or output kVA is equal to, this is the induction kVA, okay, power transferred through electrical isolation part of the winding, induction kVA plus conduction kVA or conduction capacity of the auto transformer. And how do we get induction kVA in terms of the input kVA of auto transformer? So this fourth one, the induction kVA of auto transformer, so that is equal to 1 minus K times of the input kVA of the auto transformer. This is the another formula. All formulas I'm going to write here. After that we will discuss all the possibility questions based on the auto transformer. I don't want to leave single question, complete question series. Okay, you will, if you attend this class, you will know all the possibility question based on the auto transformer. That's why I mentioned that it is a very, very important class for who are preparing for the GATE and ESE preparations. Okay, and fifth formula also we have derived in the last class, that is a conduction kVA. How do we get conduction kVA? K times of the input kVA of auto transformer here. So otherwise we can also get the input kVA of auto transformer minus induction kVA or output kVA of auto transformer, or otherwise we can also get output kVA of auto transformer minus the induction kVA of auto transformer. That means enta power electric, suppose auto transformer లో two windings ఉంటాయి కదా, ఒకటి సమ్ పార్ట్ ఒక కొంత పార్ట్ కొన్ని నెంబర్ ఆఫ్ టర్న్స్ ఎలక్ట్రికల్లీ కనెక్ట్ అయి ఉంటాయి, కొన్ని నెంబర్ ఆఫ్ టర్న్స్ ఎలక్ట్రికల్లీ ఐసోలేటెడ్ అయి ఉంటాయి. ఒకవేళ పవర్ అనేది ఎలక్ట్రికల్ కనెక్టెడ్ పార్ట్ ఆఫ్ ద వైండింగ్ నుంచి సోర్స్ టు లోడ్ ట్రాన్స్ఫర్ చేసినాం అనుకోండి, ఆ పవర్ ఏమంటామంటే కండక్షన్ పవర్ అని అంటాం. ఒకవేళ పవర్ ను ఎలక్ట్రికల్ ఐసోలేటెడ్ పార్ట్ ఆఫ్ ద వైండింగ్, so electrical isolated power is transferred from the electrical isolated part of the winding from source to the load, so that power is known as induction power. Okay, so conduction power, induction power of auto transformer. So comparisons point of view, another formula here, that is a, so how do we get kVA rating in terms of the kVA rating of auto transformer? Suppose manaka టూ వైండింగ్ ట్రాన్స్ఫార్మర్ ఆటో ట్రాన్స్ఫార్మర్ కేవీ రేటింగ్ తెలిసి ఒకవేళ నువ్వు ఆటో ట్రాన్స్ఫార్మర్ కేవీ రేటింగ్ ఫైండ్ అవుట్ చేయాలనుకోండి, సో ట్రాన్స్ఫర్మేషన్ రేషియో ఇచ్చిందనుకో, దిస్ కే ఈజ్ ఈక్వల్ టు 1 minus K times of the, so this is a kVA rating of a two winding transformer. This formula is a very, very important to solve the problems based on the this concept. Okay, and after that percentage losses also very important. So here percentage losses of auto transformer, the is equal to percentage total losses is equal to 1 minus K times of the percentage total losses of two winding transformer. Okay, this formula also very important, so to solve the problems. And there is the another formula, suppose total losses of auto transformer, total loss of auto transformer is equal to the total loss of the two winding transformer, total loss of two winding transformers. Got it? So these are very important formula. Percentage losses are 1 minus K times of the percentage total losses of the two winding transformer, but total loss of auto transformer is equal to the, this is the total loss of the two winding transformer. So if conversion takes place, okay, if it is converted, Okay, if it is converted from the two winding transformer. Okay, అంటే మనం ట్రాన్స్ఫార్మర్ లాసెస్ ఒక టూ వైండింగ్ ట్రాన్స్ఫార్మర్ ఇచ్చి ఆటో ట్రాన్స్ఫార్మర్ గా కన్వర్ట్ చేయాలనుకున్నప్పుడు పర్సెంటేజ్ లాసెస్ చేంజ్ అవుతాయి కానీ టోటల్ లాసెస్ అనేవి total losses in the kilowatts or watts the remain same. Okay, this is the this what is the reason here kVA rating will be changed, due to which percentage losses also will be changed. So that's why we have written as percentage losses of auto transformer is equal to 1 minus k times of the percentage losses of the two winding transformer. So it is a very important relation to answer the question based on the auto transformers. Okay, and next one, another formula, percentage impedance of the auto transformer is equal to 1 minus k times of the percentage impedance of the two winding transformers. When next one, another formula here, weight of the copper material. Okay, weight of copper in case of auto transformer, so that is equal to 1 minus k times of the weight of the copper. Okay, weight of copper material in case of the two winding transformers. So next, another 11th formula here, so this is also very important, percentage voltage regulation of auto transformer, so that is equal to 1 minus k times of the percentage voltage regulation of the two winding transformer. So all these okay, ఈ ఫార్ములాస్ అన్ని కూడా నేను ఇప్పుడు ఇక్కడ రాస్తున్నాను, కానీ ఈ ఫార్ములాస్ ప్రతి డెరివేషన్ నేను లాస్ట్ క్లాస్ లో డిస్కస్ చేశాను. అంటే ఇన్పుట్ కేవీఏ అవుట్పుట్ కేవీఏ ఏమవుతుంది, ఇన్పుట్ కేవీఏ ఇండక్షన్ కేవీఏ, ఓకే, కేవీ రేటింగ్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్, పర్సెంటేజ్ లాసెస్, టోటల్ పర్సెంటేజ్ ఇంపిడెన్స్, వెయిట్ ఆఫ్ ద కాపర్. సో ప్రతి ఫార్ములాకు డెరివేషన్ నేను లాస్ట్ క్లాస్ లో డిస్కస్ చేశాను. So last lecture number. So if you want to go through these derivations, okay, go through this part. So if you want to know about all the derivation of these formulas, so lecture number 41 and 40. Okay, this is the lecture number 41 and 40. So 40 and 40. Okay, this go through these lectures. You will get all the derivation part for each and every formula. Okay. So now we will discuss. Okay, auto transformers లో చాలా వరకు ఒకటే ప్రాబ్లం 2-3 మెథడ్స్ లో కూడా చేయొచ్చు. I will discuss all the points. Okay, all possible methods to answer each and every question. Okay, so this is the one of the question. Let us assume this is the question number 1. Anyone can answer? Gayatri, first to read the question. ఓకే, మీరు క్వశ్చన్ పర్ఫెక్ట్గా రీడ్ చేయండి. సో ఎలా అయినా ఫైండ్ అవుట్ చేయొచ్చు. ఏ సింగిల్ పేజ్ ట్రాన్స్ఫార్మర్ యాజ్ ఏ రేటింగ్ ఆఫ్ 15 kVA. ఓకే, సింగిల్ పేజ్ ట్రాన్స్ఫార్మర్ యాజ్ ఏ రేటింగ్ ఆఫ్, హియర్ గివెన్ దట్ 15 kVA and voltage rating also given 600 upon 200 volts. Okay, it is a single phase transformer. So it is reconnected as an auto transformer so to supply at 720 volts from the 600 volts as a primary. Okay, so here is a rating of the two winding transformer. So this is a rating of two winding transformer. Okay, so aim rating ichadu ikkada 15 kVA rating. Okay, this is the VA rating of two winding transformer. So next 600 volts and 120 volts. Okay, so 600 volts is a EHV. Okay, high voltage of two winding transformer, and this one is the ELV, low voltage of the two winding transformer. So similarly the rating of the two winding transformers kuda mana ee problem lo ichchadu kabatti, so this is the rating, voltage rating of the rating of two winding auto transformer. So that voltage rating, so it is a 720 volts we got from the 600 volts as a primary. So 600 upon 720 volts. So 600 is this is the V1 primary voltage, and this one is the V2 here. So how do we get this 600 and 720 volts? Whenever these two windings are ఒకవేళ ఈ హెచ్వి అండ్ ఎల్వి వైండింగ్స్ మనకు సిరీస్ అడిటివ్ పొలారిటీలో కనెక్టెడ్ అయినప్పుడు మాత్రమే అవుట్పుట్ వోల్టేజ్ 720 అనేది వస్తాయి. సపోజ్ నేను ఇలా కనెక్ట్ చేసిన అనుకోండి. సో దిస్ ఇస్ ద 600 volts. Okay, we have given as a 600 volts. Okay, and it is the EHV. And another one, it is connected to the same series additive polarity manners. So series additive polarity manners means, okay, like this we are connected. So then only the net voltage the across these two windings we will get the 720 volts. Like this we can get, okay, it is a V2 here. So it is equal to the 720. Just apply the KCL here. So that KVL plus and minus. Okay, minus 2 plus. Okay, this value is equal to minus 600. Okay, minus 2 plus minus 120. Okay, it is the plus 2 minus. So that it is the plus. Okay, V2 is equal to 0. So therefore here V2 is equal to 720 volts. So this is the 720 volts. Okay, and the supply is given the here. It is excited with the rated high voltage. Then what will happen? So it is the V1 is equal to 600 volts. Okay, this is the series additive polarity connection. Additive polarity connection of auto transformers. Okay, ఇప్పుడు మనం రేటింగ్స్ బట్టి మనం this is the V1 and V2. Supply voltage V1 600 volts, output voltage is 720 volts. Okay, anyone can answer this? Okay, మీకు వచ్చిందా గాయత్రి? Have we got it? ఎలా క్యాలిక్యులేట్ చేస్తాం? సో ఆల్రెడీ నేను మెన్షన్ చేశాను కదా ఇన్పుట్. ఓకే, దిస్ వన్ ఇస్ ద ఒక ఇయర్ వి విల్ గెట్ ద I1 కరెంట్. ఒక ఇయర్ ఇస్ ద I1 అండ్ దిస్ ఇస్ ద I2. ఒక I2 1. సో హౌ డు వి గెట్ I1? ఒక ఇయర్ I1 is a, so always in the series additive polarity connect ILV plus IHV value. Okay, and it is the low voltage winding, so that it is equal to ILV value. Okay, IL. So by using this KVA rating and this value we can get ILV and IHV value, and after that here this we will get V1 and V2 parameters. So now let us find out first method. So this is the method 1. I will discuss all the possible methods. So KVA rating of auto transformer, is equal to 1 by 1 minus K times of the KVA rating of the 2 winding transformer. Okay, so we don't know what is the value of the K. K ఎలా find out చేస్తాం? So where K is equal to K, low voltage of auto transformer divided by high voltage of the auto transformer. Okay, this is the one method. So what is the low voltage of auto transformer? See here. Okay, మనకి 600 and 700 అని ఇచ్చింది కదా. So ఇది low voltage of the auto transformer. Okay, and this 720 volts is a high voltage of auto transformers. Okay, got it my point? So low voltage of auto transformer, high voltage of the auto transformer. So now find out this one is the low voltage is a 600 and divided by high voltage is a 700 volts. Okay, 600 volts and 700 volts. So now kVA rating of auto transformer is equal to, so 1 by 1 minus 600 upon 700 volts, 600 upon 720 volts multiplied by, okay, kVA rating of two winding transformer which was given in the question. So that is a 15 kVA. 15 kVA. Okay. So now calculate, you will get a answer. Okay, use a calculator, all of you. How do we get this answer? So it is a 720 divided by 120, okay, multiplied by 15. Okay, it is equal to 90 kVA. So this is the answer for this question. It is the method 1. Okay, we can answer like this. Okay, this is a one method. And also we can answer this question another way also. That is the second one, method number 2. So method number 2 ela calculate system. So input kVA of auto transformer. Input kVA of auto transformers. So how do we get input kVA of auto transformer? V1 multiplied by I1. So we have, this is the diagram, right? So it is a input kVA of auto transformer. Let us find out complete. Just wait a minute. So this is our diagram. So we have to find out I1 and it is a ILV values. Okay, here I1 is equal to, so this one is a, where V1 is equal to how much? Where V1, so it is equal to 600 volts. And I1 is equal to ILV, I1 is equal to ILV plus IHV value. Okay, IHV values here. So ILV is equal to 15 kVA, 15 into 10 to the power of 3. Low voltage of the two winding transformer. What is the low voltage of two winding transformer? ILV is equal to 120. Okay, 120 volts. Now plus IHV is equal to, so this is a IHV values, the 15 into 10 to the power of 3 divided by the 600 volts. So now simplify, you will get I1. Very good, Gayatri. So now calculate this part, method number 2. Same question we can answer another way also by using the transformation ratio. Suppose if you don't know the formula, use this method. Okay, 15 into 10 to the power of 3 divided by 120. 15 into 1000 divided by 120. Okay, it is equal to 125 amps. So next one, 15,000 divided by 600. Okay, it is equal to 25. So now total equal to 150 amps. So now we can find out input kVA of auto transformer. The input kVA of auto transformer, so our kVA rating of auto transformer, that is equal to, it is also called kVA rating of auto transformer. Okay, how do we get? So input kVA V1 multiplied by I1. So V1 is equal to how much? 600. Okay, I1 enta? So I1 150 kada. So calculate cheyandi, 600 into 150, it is also we will get 90 kV. Like this also we can answer this question. Very good. That's correct. So next, let us solve this question by using another method also. Method number 2. Method number 3. Okay, like this also we can answer. So first let us take circuit of this figure. That's the question. So this is the circuit diagram. So in terms of the output parameters also we can find out the kVA rating. How do we get in output kVA of auto transformer? So that is a V2 multiplied by I2. So V2 is a, let us find out V2. What is the value of V2? It was given 720 volts. 720 volts. Okay, got it. And I2, how do we get I2? I2 is a equal to here. I2 is equal to, this is the ILV. Okay, here ILV value. So this I2 is equal to ILV. So here ILV in the sense it is the 125. Okay, here already we got ILV value 125 amps. So that we can write 125 amps. Or otherwise you can write, so it is a 15 into 10 to the power of 3 divided by low voltage 120. So that you will get 125 amps. Okay. And after getting kVA rating of auto transformer is equal to auto transformer. So that is equal to, so it is a V2 is equal to 720 and I2 equal to 125 amps. So 720 volts, 125 amps. Okay, this was is equal, this will be 90 kVA. Okay, ila 3 methods మీకు ఏది కన్వీనియంట్ ఉంటే ఆ మెథడ్ యూజ్ చేసి మీకు ఈ ఆన్సర్స్ ఫైండ్ అవుట్ చేయొచ్చు. ఒకటి, ట్రాన్స్ఫర్మేషన్ రేషియో యూజ్ చేసి కూడా మనం ఆటో ట్రాన్స్ఫార్మర్ను ఆటో ట్రాన్స్ఫార్మర్ రేటింగ్ ఫైండ్ అవుట్ చేయొచ్చు. అలా కాకుండా ఇన్పుట్ పారామీటర్స్ ఆఫ్ ద ఆటో ట్రాన్స్ఫార్మర్, by using input parameters of auto transformer also we can find out the kVA rating of auto transformer. And next one, by using output parameters of the auto transformer also we can find out the kVA rating of auto transformers. All of it clear now? Like this you can calculate method 1, method 2, method 3. Any more doubt? Is that clear everyone? So now let us solve one more question. Question number 2. An auto transformer having the transformation ratio. Okay, this was given, transformation ratio is 0.8. Supplies a load of the 10 kilowatts. So the power transferred inductively from the primary to the secondary side. So already mentioned that input power of the auto transformer, input power, the equal to output power of the auto transformer. So this is equal to, so here induction power or induction kVA, so plus the conduction power. So power which transferred from the source to the load, electrical isolated part of the winding is known as a induction power. The power transferred, so power which transferred from the source to the load, electrical connected part of the winding is known as conduction power. So electrical connection gunda source nunchi load power transfer cheste aa power nu manam induction power ani antam. Ala electrical power lo, so electrical connection part of the winding lo మనం సోర్స్ నుంచి లోడ్ పవర్ ట్రాన్స్ఫర్ చేస్తే ఆ పవర్ ను మనం కండక్షన్ పవర్ అని అంటాం. సో హౌ డు వి గెట్ ఇండక్షన్ పవర్ ఇన్ టర్మ్స్ ఆఫ్ ద ఇయర్? సో హియర్ వి రిక్వైర్డ్ ఇండక్షన్ పవర్. హౌ డు వి గెట్ ఇండక్షన్ పవర్? induction power is equal to induction power that equal to 1 minus k times of the input power or output power of the auto transformers. Okay, so input power or the supply is a load of, so this also we can write 1 minus k times of the output power of auto transformers. Okay, so now where k is equal to, so this was given 0.8, so now 1 minus 0.8, so into, okay, this is the 10 kilowatts, so now it is equal to 0.2, so it is equal to 0.2 into the 10 kilowatts. Okay, therefore how much, so this was is equal to, okay, it is a 1 minus 0.2 here, so it is a 2 kilowatts. Okay, 2 kilowatts power. Very good. Good evening, Nageshwar. Very good. So answer for this question, it is a 2 kilowatts. Next, solve one more question, question number 3. So this was given IS 2000. Here in an auto transformer, voltage ratio V1 by V2. Okay, this is the V1 by V2, where V1 is greater than the V2. The fraction of the power transferred inductively. Fraction of power transferred inductively, that is the induction power only required. Fraction is required, that means induction power divided by the input kVA of auto. That is the k value we have to find. So now fraction of the power transferred inductively. Okay, mark this. Okay, we know the formula here. Induction power is equal to, so that is equal to 1 minus k times of the input kVA, input power of auto transformer. Okay, so that is the induction power of auto transformer is equal to 1 minus k times of the input power of the auto transformer. How do we get this? Okay, 1 minus here induction power of auto transformer divided by input power of auto transformers. Okay, got it? So it is equal to 1 minus k, 1 minus k value. So clear point. So this is the where k is equal to. How do we get the k here? I already mentioned that k అనేది ఎప్పుడు కూడా low voltage of auto transformer by high voltage of the auto transformer. Okay, don't take like high voltage and here. Always in step up or step down auto transformer. So k is nothing but here k is a transformation ratio. So where k is a, okay, here k is transformation ratio. Transformation ratio. So this k is always the low voltage of auto transformer divided by high voltage of the auto transformers. Okay, got it point? Low voltage of auto transformer. So which one is a low here? V1 by V2 ratio is given, but here V2 is a low. Okay, this is a low and this one is a high value. So now here this is equal to V2 by V1. So now substitute here, this value is equal to 1 minus k is equal to V2 by V1. So where V2 by V1 is equal to V1 minus V2 divided by V1. Like this we have to answer. So that what is answer? V1 minus V2 divided by V1. So option D is a correct. Very good. Like this we have to answer this question. Next one. Are you clear? Is that clear everyone? Nageshwar, Gayatri. Now let us solve one more question. Question number 4. Today we will discuss all possibility question based on the auto transformer. The complete question series gate lo IES lo ఎన్ని క్వశ్చన్స్ ఉన్నావో అన్ని క్వశ్చన్స్ ఈరోజు డిస్కస్ చేస్తాను మీతో. ఓకే, ప్రతి క్వశ్చన్ is it a theoretical question or whether it is a theoretical question or problematic, whether it is a small or the very easy question or difficult question, I will discuss everything. After this class we don't have any doubts about how to solve these problems based on auto transformer. That my motto. Very good, very good. So now calculate what is the answer for this question. See here, all of you. In case of auto transformer, which of the following statements are correct? Okay, one statement is given: an auto transformer requires less copper as compared to the conventional auto two winding transformer. An auto transformer provides isolation between the primary and secondary windings. Okay, and another statement is an auto transformer has less leakage reactance as compared to the conventional two winding transformer of the same capacity. What is the answer? Less leakage reactance as compared to the conventional of the same capacity. Option C. Okay, see, first one, auto transformer requires less amount of the copper as compared to the conventional two winding transformer. So from the statement 1, okay, see here, from statement 1, so here we know that, so weight of the copper, okay, here is a weight of copper, so is equal to, in case of auto transformer, is equal to 1 minus k times of the weight of the copper in the two winding transformer. So arbitrary, let us take example point. I have taken this is the example point of view. So here k is equal to, the example k is a 0.5. Assume as a k is equal to 0. So therefore here weight of the copper in auto transformer is equal to 1 by 2 times of, okay, weight of the copper in two winding transformers. Okay, so వాళ్ళ two winding transformers లో 50% ఆఫ్ కాపర్ ఉందనుకోండి, సో నువ్వు ఆటో ట్రాన్స్ఫార్మర్స్ లో ఎంత కాపర్ రిక్వైర్మెంట్? ఓన్లీ 50% ఆఫ్ ద కాపర్. సో దట్ ఈస్ ఏ వెయిట్ ఆఫ్ ద కాపర్ ఈజ్ అ లెస్ యాజ్ కంపేర్ టు ద two winding transformer. So this statement is a correct. Okay, next one, and from this statement to 2, then see, an auto transformer provides the isolation between the primary and secondary. No, some part of the turns are electrically connected. ఒక నువ్వు ఆటో ట్రాన్స్ఫార్మర్ లో 100 టర్న్స్ ఉన్నాయనుకోండి, దాంట్లో ఒక 60 నెంబర్ ఆఫ్ టర్న్స్ అనేది ఎలక్ట్రికల్ గా కనెక్ట్ అయి ఉంటాయి. సో నెక్స్ట్ వన్, the remaining 40 నెంబర్ ఆఫ్ టర్న్స్ ఆర్ ఎలక్ట్రికలీ ఐసోలేషన్ అయి ఉంటుంది. సో నౌ యూ కెనాట్ గెట్ పర్ఫెక్ట్ ఐసోలేషన్ between the primary and secondary by using auto transformer. This is one of the disadvantage or limitations of the auto transformer. So auto transformer cannot be used as a isolation transformers wherever isolation required between the LV winding and HV windings. Okay, so that the statement is wrong. Okay, and next coming to the third one, auto transformer has less leakage reactance as compared to the conventional. Similar way, what is the percentage, the leakage reactance, percentage reactance of auto transformer? This is the from the statement 3. Okay, here, so from the 3 statement, it is equal to 1 minus k times of the percentage reactance of the two winding transformer. So example point assume as a k is equal to 0.5. ఓకే, k అనేది 0.5 తీసుకోండి. సో నౌ k ని ఇక్కడ సబ్స్టిట్యూట్ చేస్తే ఎంత వస్తుంది? పర్సెంటేజ్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్ ఈజ్ ఈక్వల్ టు 1/2 times of the percentage of reactance of the two winding transformer. ఓకే, ఇది కూడా 50% ఉంటుంది. సో నౌ స్టేట్మెంట్ 3 అనేది కూడా కరెక్ట్. పర్సెంటేజ్ ఆఫ్ less value as compared to the two winding transformer. So now here options are correct. Option 1, 2, 3 is given, it is a wrong. 1 and 2 it is also wrong. 1 and 3, so it's correct, and 2 and 3 it's a wrong. Very good. Are you clear now? Is that clear, everyone? So now let us solve this question. Okay, this was given IAS 2002. How do we answer this question? A two winding transformer used on a auto transformer. The kVA rating of auto transformer compared to the two winding transformer will be. Okay. Option A 3 times, option B 2 times, option C 1.5 times, and option D same. ఎలా చేస్తుంది చెప్పండి? ఫస్ట్ ఈ ప్రాబ్లం నీకు k వాల్యూ తెలిస్తే ఇట్ ఈస్ అ వెరీ ఈజీ. Okay, we know that. So kVA rating of auto transformer is equal to kVA rating of auto transformer, that is equal to 1/1 minus k times of the kVA rating of the two winding transformer. So this relation is required to answer this question. Now here k అనేది మనకు ఒకవేళ ప్రాబ్లంలో ఇవ్వలేదు అనుకోండి. సో k అనేది రేంజ్ ఎలా ఉంటుందంటే, సపోజ్ నీకు రేంజ్ ఆఫ్ ద k ఆల్రెడీ డిస్కస్డ్ ఇన్ ద థియరిటికల్ క్లాస్. సో ఆల్వేస్ ఇన్ ఆటో ట్రాన్స్ఫార్మర్ ఇన్ రేంజ్ ఆఫ్ ద k in auto transformer, so that is equal to, so this one is the first point about the k, about the transformation ratio k here. Okay, this is the first point here, range of the k. So k అనేది ఇవ్వలేదు అనుకోండి, రేంజ్ ఆఫ్ ద k ఎలా ఉంటుంది? సో ఇట్ ఈస్ గ్రేటర్ దాన్ ద 33.3%. k is greater than 30 and less than the 1. So this is the range of the k. Okay, and desirable value of the k. Okay, sometimes we have a question. So what is the desirable value? Desirable value of the k1. Okay, desirable value of k. నువ్వు డిజైరబుల్ వాల్యూ అనేది ఎలా ఉండాలా? ఒకవేళ నీకు 0.33.3 టన్స్, ఒకవేళ 100 నెంబర్ ఆఫ్ టన్స్ ఉన్నాయనుకోండి. సో నువ్వు 100 నెంబర్ ఆఫ్ టన్స్ లో నువ్వు ఓన్లీ 20 టన్స్ ఆర్ ఎలక్ట్రికల్ కనెక్ట్ చేసి 80 టన్స్ ఆర్ ఎలక్ట్రికల్లీ ఐసోలేటెడ్ పెట్టినామనుకోండి, వీ కెనాట్ గెట్ మోర్ అడ్వాంటేజెస్ ఇన్ ద ఆటో ట్రాన్స్ఫార్మర్, విచ్ ఈస్ నాట్ ఎ ఫిజబుల్ కండిషన్. మనం అలా కనెక్ట్ చేసి కూడా యూజ్ లేదు ఆటో ట్రాన్స్ఫార్మర్స్. ఓకే, నువ్వు ఒకవేళ ఆటో ట్రాన్స్ఫార్మర్ మనం రీకనెక్ట్ చేయాలంటే ఎలా కనెక్ట్ చేయాలా? నువ్వు 80 టన్స్ ఎలక్ట్రికల్ గా కనెక్ట్ అయ్యి 20 టన్స్ అనేవి ఎలక్ట్రికల్ ఐసోలేటెడ్. సో దట్స్ వై కండక్షన్ పవర్ ఇస్ అ మోర్ యాజ్ కంపేర్ టు ద ఇండక్షన్ పవర్. సో డిజైరబుల్ వాల్యూ అనేది ఎలా ఉండాలి అంటే కంపల్సరీ నియరర్ టు ద 1 ఉండాలి. ఒక నియరర్ టు ద 1. సో దిస్ ద డిజైరబుల్ వాల్యూ ఆఫ్ ద k. ఒకవేళ k అనేది మనకు తెలియకపోతే అప్పుడే వాల్యూ తీసుకోవాలా k అనేది. సో కంప్లీట్ గా k అనేది మన క్వశ్చన్ లో ఇవ్వకపోతే నువ్వు ఎకనామికల్ పాయింట్ ఆఫ్ వ్యూలో చూసుకోవాలి. అంటే డిజైన్ చేసేటప్పుడు నీకు కాస్ట్ అనేది చాలా ఇంపార్టెంట్ కదా. సో ఎకనామికల్లో సో ఎలా k వాల్యూ ఉంటుంది? ఎకనామికలీ సో ఇయర్ k is equal to 0.5. So these are the about the transformation ratio. The range of the k. So here, in order to get the more advantages in a auto transformer, the k should be nearer to the 1. Economically, k is equal to 0.5. Okay. Suppose, therefore, we have taken here the k is equal to 0.5. Okay. So now KVA rating of auto transformer is equal to the 1 by 1 minus k is equal to 0.5. So multiplied by KVA rating of 2 winding transformer. So now therefore simplify here, 1 by 2 here, 2 times of the KVA rating of the 2 winding transformer. So we have to do like this. అలా క్లియర్ మా పాయింట్. కే అనేది మనం ఒకవేళ ఏ క్వశ్చన్ లో కూడా కే అనేది మెన్షన్ చేయకపోతే నువ్వు ఎకనామికల్ పాయింట్ ఆఫ్ వ్యూలో తీసుకోవాలి. ఒకవేళ డిజైరబుల్ అని మెన్షన్ చేస్తే నియరర్ టు ద 1. ఓకే, అలా క్లియర్ నౌ? ఇస్ దట్ క్లియర్ ఎవ్రీవన్? ఓకే, అర్థమైందా ఎలా చేయాలనేది ప్రాబ్లం? సో దట్ ఆన్సర్ ఈజ్ 2 times ఆఫ్ ద దిస్ రేటింగ్. వెరీ గుడ్ నాగేశ్వర్, యు గాట్ ఇట్. వాట్ అబౌట్ గాయత్రి? నెక్స్ట్ కెన్ దిస్ క్వశ్చన్ నెంబర్ 5th. okay, so now let us solve one more question based on this concept. Okay, so this was given IAS 2005, the question number 6. So a single phase 10 kVA 200 upon 200 volts 50 Hz transformer is connected to form an auto transformer as shown in the figure. Okay, as shown in the figure given. What are the values of V1? What are the values of V1 and I2? Okay, ila connect చేసినప్పుడు, so what are the values of the V1 and the I1 here? So now first one, see here. So it is a dotted. Okay, here is a dot and this one is the undotted terminal. Okay, and here also dotted and undotted terminals. Okay, this is the so assume as a dot is a plus, undotted is a minus, dot is a plus and undotted is a minus. So now apply the KVL in this loop here, the by KVL. Okay, in the loop. Okay, it is the input side. Okay, here. So by KVL equation, by KVL in input loop, okay, apply the KVL in the input loop, we get, okay, minus V1. Okay, minus V1. So now this is a equal to, okay, this value is equal to, how do we get? Okay, minus E1 here. So let us assume this is the, okay, here E 2000 is a here EHV, ELV, and this one is the EHV value. Okay, EHV is equal to 2000. Okay, here is a ELV is equal to here. So this is a 200, right? So therefore it is equal to the minus 200, the plus, okay, it is a 2000 is equal to 0. So here V1 is equal to 1800 volts. Okay, it is a 2 winding transformer which was given 2 winding. So now here EHV and supply side here. So next we required I2 current. How do we get I2? Okay, this is the series subtractive polarity. Okay, series subtractive polarity here. So now this I2 is equal to, okay, in series subtractive polarity of auto transformer. Okay, their I2 is equal to how much? So ILV minus IHV value. Series subtractive polarity of auto transformer, ILV minus IHV, where ILV is equal to how much? This is the current ILV. So where ILV is equal to ILV. So now it is a VA rate, KVA rating of two winding transformer divided by ELV value. Okay, so it is equal to KVA rating is a 10 kVA, the 10 into 10 to the power of 3 divided by E is equal to 200. So it is equal to 50 the kV, 50 amps. Okay, next one, IHV is equal to KVA rating of the two winding transformer divided by EHV. EHV value. So how do we get this one? EHV here 10 into 10 to the power of 3 divided by 2000. So now it is equal to how much? Okay, 10 into 2000 and 10,000. So now it is equal to 5 amps. Okay, 5 amps here. Now simplify here. I2 is equal to where I2 value, so that is equal to ILV minus IHV value. So ILV is equal to 50 minus 5. Okay, it is equal to 45 amps. Very good. So my series R2 polarity of auto transformers అనేది నేను లెక్చర్ నెంబర్, okay, if you have a lecture number 41, సో మీ ఈ లెక్చర్ నెంబర్ 41 లో నేను డిస్కస్ చేశాను కంప్లీట్ గా. సో మీకు ఈజీగా అర్థమవుతుంది సిరీస్, వాట్ ఈస్ ద మీనింగ్ ఆఫ్ సిరీస్ R2 polarity. So yes, it's additive polarity, subtractive polarity. So subtractive polarity means LV winding and HV winding of the two winding transformers are connected in the series in such a way that fluxes are produced by these two windings are in the opposite direction. So therefore here net voltage is equal to, so difference of the these 1800 minus 200, you can answer this. So now currents also difference of the two currents. Okay, here no need, by seeing this only one word you can answer easily. So here supply, the net voltage is a difference, current also different. Suppose series subtractive, ఒకవేళ స్టార్ ఇలా కాకుండా ఈ డాట్ అనేది ఇక్కడ ఇచ్చింది అనుకోండి, ఒక ఇన్స్టా ఇదే క్వశ్చన్ లో ఇక్కడ డాట్ ఇచ్చింది అనుకోండి, ఈ V1 ఏమవుతుంది చెప్పండి? కెన్ యూ టెల్ మీ దిస్ వన్? క్వశ్చన్ అనేది సేమే, అలా కాకుండా డాట్ ఇక్కడ ఇచ్చేసింది అనుకోండి ఇక్కడ, ఓకే, ఈ డాట్ ఇక్కడ నుంచి ఈ ప్లేస్ లో కాకుండా ఈ ప్లేస్ లో డాట్ ఇస్తే వాట్ ఈస్ ద ఆన్సర్స్ E1 అండ్ V2 హియర్? గాయత్రి, నాగేశ్వర్, పవన్, కెన్ యూ ఆన్సర్ దిస్? ఒక నేను డాట్ ఈ పొజిషన్ లో డాట్ ఇచ్చింది కాబట్టి ఇది ఆన్సర్ 1800 volts అండ్ 45. నేను అలా కాకుండా డాట్ ఇక్కడ ఇచ్చినాను అనుకోండి, అప్పుడు ఏ కనెక్షన్ అవుతుంది? ఇది గివెన్ ట్రాన్స్ఫార్మర్ కనెక్షన్ అనేది సిరీస్ సబ్ట్రాక్టివ్ పొలారిటీ. ఒక ఇయర్ ఇస్ సారీ సిరీస్ అడిటివ్ పొలారిటీ కనెక్షన్. సో ఇన్ సిరీస్ అడిటివ్ పొలారిటీ కనెక్షన్ నెట్ వోల్టేజ్ ఈజ్ ఈక్వల్ టు EHV ప్లస్ ELV అండ్ కరెంట్ అనేది నెట్ కరెంట్ ఏమవుతుంది? టోటల్ కరెంట్ ILV ప్లస్ IHV. సో కరెంట్ అనేది వోల్టేజ్ 2200 volts అండ్ కరెంట్ అనేది 55 amps అలా. ఓకే, సో there are some variations. Suppose if I take the variations in this problem, just wait. ఓకే, సేమ్ క్వశ్చన్ మనకు ఇలా మెన్షన్ చేసిన అనుకోండి, డిఫరెంట్ టైప్ ఆఫ్ వేరియేషన్స్ ఉంటాయి. ఓకే, క్వశ్చన్ సేమే, ఇది V1, ఒక V1, ఓకే, ఇది I2, ఓకే, ఈ కరెంట్ ఇచ్చాడు 5 amps. ఓకే, నౌ దిస్ వోల్టేజ్ కూడా ఇచ్చేసాడు 200 volts, 2000 volts. ఓకే, సో నెక్స్ట్ నేను డాట్ ఎలా ఇస్తానంటే, సో ఇలా యాక్చువల్ ప్రాబ్లంలో ఇక్కడ ఇచ్చాడు కాబట్టి ఆ డాట్ నేను ఇక్కడ ఇస్తున్నాను. సో ఇయర్ ఫర్ ఎగ్జాంపుల్ ఇట్ ఇస్ ద కేస్ 1 అనుకోండి, కేస్ 1. అప్పుడు V1 ఏమైతే చెప్పండి. సో ఫస్ట్ టెల్ మీ విచ్ కనెక్షన్ ఇయర్. This is the in a loop here, in this loop. So here current is a here dot at entering position of the coil. So this is the LV winding and this one is the HV winding. So here is a current entering, this one is a suppose, so it is a plus, okay, and with respect to the other terminal. So now this one is a plus with respect to the other terminal. So these two windings are connected in series additive polarity connection. So that here it is the series additive polarity of auto transformer. Polarity of auto transformer. So ఈ సిరీస్ additive polarity of auto transformer లో నెట్ వోల్టేజ్ ఏమవుతుంది ఈ లూప్ లో. సో నెట్ వోల్టేజ్ ఇన్ ఏ లూప్ ఈ నెట్ ఈజ్ ఈక్వల్ టు EHV ప్లస్ ELV. ఒక ఇలా క్యాలిక్యులేట్ చేయండి. సో EHV ఎంత, ఒక HV వోల్టేజ్ 2000 కదా. సో ELV 200. సో నౌ ఇట్ ఈస్ ఈక్వల్ టు 2200 volts ఒక EL. సో నెక్స్ట్ కరెంట్ ఇయర్ నెట్ కరెంట్ ఏమవుతుంది, దిస్ EHV ఇన్ ద E net ఈస్ ఈక్వల్ టు ఇన్ ద సెన్స్ ఇట్ ఈస్ ద V1. సో నౌ I2 ఇన్ ద మీన్స్ ద I2 ఈస్ ద నెట్ కరెంట్ ఎట్ దిస్ KCL. ఒక నెట్ కరెంట్ ఈస్ ఈక్వల్ టు, సో I net, so that is equal to ILV plus IHV1. Okay, this is equal to the 50, the plus 5, okay, that is equal to the 55 amps. Okay, like suppose అలా కాకుండా నీకు ప్రాబ్లం సేమ్ క్వశ్చన్ డాట్స్ అనేవి చేంజ్ చేశాడు అనుకోండి. సో ఇలా డాట్స్ ఓకే సేమ్ క్వశ్చనే ఓకే, ఇది 2000 volts. ఓకే, ఇన్పుట్ సైడ్ అనేది మనం ఫైండ్ అవుట్ చేయాలా. ఇది V1 volts. ఓకే, సో LV వైండింగ్, దిస్ వన్ ఇస్ ద LV వైండింగ్ అండ్ దిస్ ఇస్ ద HV వైండింగ్. ఓకే, నెక్స్ట్ డాట్స్ ఎలా ఇచ్చాడు అనుకో, సపోజ్ ఇయర్ డాట్ అండ్ దిస్ పొజిషన్ దగ్గర డాట్ ఇచ్చింది అనుకోండి. సో నెక్స్ట్ ఎలా దిస్ వాట్ ఇస్ ఆన్సర్ ఫర్ దిస్ క్వశ్చన్. ఈ కరెంట్ ఇచ్చేసాడు మనకు, దిస్ కరెంట్ ఇయర్ 5 amps. నౌ లెట్ us find out V1 and V1 and I2. ఓకే, క్వశ్చన్ సేమే కానీ డాట్స్ పొజిషన్ ఆఫ్ ద డాట్ అనేది చేంజ్ చేస్తే నీకు V1 అనేది V2 అనేది ఎలా చేంజ్ అవుతుంది. Okay, so now tell me the answer for this question. What is the answer here? This connection is just check it. Okay, dot always considered as a positive sign. Already we have discussed in the polarity test. So plus minus, okay, it is a minus to the plus. So just here apply in this case. So what will happen? So by KVL equation you can write directly also. By KVL equation it is a plus 2 minus, okay, this one is the minus V1, the plus, okay, 200, the minus 200 minus 1800, so that is the minus 2000. So now it is equal to, so here 0, so that V1 is equal to 200 to 1800 volts. Okay, or other way also we can find, always net voltage is equal to here connected here series subtract to polarity, series subtract to polarity of auto transformer. So that's why EHV minus VLV. So it is equal to how much? 1800 volts. Okay. Now current ఎలా ఉంటుంది I2. So difference of these two currents I2 I the IHV minus ILV. Okay, it is equal to, so IHV minus ILV, it is a 45 amps. Like this we have to calculate. Question is the same. So if it is given like, if the figure is given is like this. So okay, so case, it is the question number 2 and question number 3. Like, all of it clear now? Is that clear everyone? అర్థమైందా అందరికి? Let's move on another question. చాలా ఈజీ. మీకు కాన్సెప్ట్ క్లియర్ ఉన్నారు అనుకోండి, ప్రాబ్లమ్స్ చాలా ఈజీ. కంపల్సరీ ఆటో ట్రాన్స్ఫార్మర్లో ఒక క్వశ్చన్ వస్తుంది. నువ్వు ట్రాన్స్ఫార్మర్స్లో ఒక 5 మార్క్స్ ఉన్నాయనుకోండి గేట్లో, సో ట్రాన్స్ఫార్మర్స్కి వెళ్ళి ఒక క్వశ్చన్ కంపల్సరీ ఉంటుంది. చాలా ఇంపార్టెంట్ పార్ట్, ఈజీ, చాలా ఇంపార్టెంట్ కూడా. నీకు కాన్సెప్ట్ క్లియర్ ఉంటే చాలా ఈజీగా చేయొచ్చు. వెరీ గుడ్. So now let us solve one more question. Okay, now tell me this answer. Question number 7, right? 6 and this one is the 7. What is the efficiency of auto transformer in comparison to the 2-winding transformer of the same rating? Okay, what is the answer for this question? What is the efficiency of auto transformer in comparison to the 2-winding transformer of the same rating? Slightly less than the 2-winding transformer, same as that of the 2-winding transformer, more than that of the 2-winding transformer, as low as 1/5 of the efficiency of the 2-winding transformer. What is the answer? Efficiency of the auto transformer. Okay, efficiency of auto transformer is more as compared to the 2-winding transformers. Okay, so here losses are same. Okay, actually the here losses remain same, but KVA rating is a different. So because of this reason, then what will happen? So efficiency of auto transformer is more as compared to 2-winding transformer. Okay, since KVA rating of auto transformer is more as compared to the 2-winding transformers. Okay, so we know that KVA ratings. Okay, this is a KVA rating and losses, already we have discussed that part. So that is the KVA rating of auto transformer is equal to 1/1 minus K times of the KVA rating of the 2-winding transformers. Okay, so now here KVA rating is a more as compared to the 2-winding transformer. So efficiency of auto transformer is a more as compared to the 2-winding transformers. Okay, option C is a correct for this question. Next one, can you tell me the answer for this question? The next question, question number 8. This is also given in IS 2009. What is the power transmitted inductively in an auto transformer which supplies a load at 161 volts with an applied primary voltage of the 230 volts? Okay, load voltage is a 160 volts and primary voltage is a 230 volts. So we required power transmitted inductively in terms of the input. Option A is given 35% of the input, option B is the 75% of the input, option C the 15% of the input, and option D the 30% of the input. So ఎలా క్యాలిక్యులేట్ చేస్తాం? మనకు ఫార్ములా తెలుసు కదా, ద ఇండక్షన్ పవర్ ఈజ్ ఈక్వల్ టు ఒక ఇండక్షన్ పవర్, సో దట్ ఈక్వల్ టు 1 minus k times of the input power. Okay, this is the formula. So where k is equal to, already mentioned, k is what is the meaning of k? Transformation ratio of auto transformers. So it is equal to, so this is a sorry, the k is a low voltage of auto transformer divided by high voltage of the auto transformers. Okay, always 16 here, low voltage by 161 divided by 230. Okay, 230 volts. Now substitute here the induction kVA or induction power of auto transformer, so that equal to 1 minus 161 divided by the 230 multiplied by the input kVA. So now it is equal to how much percentage? Now first tell me this one. 161 minus 161, calculate this part. 161 divided by 230, okay, 0.7. So 1 minus 0.7 means 0.3. Okay, 0.3 into input kVA. 0.3 is a per unit value. So now here we will get percentage value is equal to percentage value is equal to per unit value into 100. So therefore 0.3 into 100, so that is equal to 30%. Like this we have to calculate. So answer is a 30% of the input. Now is that clear everyone? So now let us solve one more question. Question number, this was previous question is a 8. Okay, this is the question number 9. So what is the answer for this question? Okay, what is the power transfer conductively from the primary to the secondary of an auto transformer having the transformation ratio 0.8 supplying the load of the 3 kilowatts? So here conductively you can get k times of the input power, here load power here. So that is the induction power is a 1 minus k, and we know that induction power is equal to induction power, so that is equal to 1 minus k times of the input kVA of auto transformer, or so that is equal to 1 minus k times of the output kVA or output power of auto transformers here, output power of the auto transformers. So therefore you can write, so that is the how do we get conduction power? Conduction power is equal to, okay, it is a 1 minus, that is the input power, or this is the conduction power is equal to input power, the input power minus the induction power. Okay, induction power here you can take output power also directly. So now this is equal to, in terms of the input power, I have taken 1 minus k. So k times of the input power. Now where this also we can write k into input kV, output kV same. So output power of auto transformer. So that's why we can write how much value, 0.8 into 3 kilowatts. Okay, that is equal to 2.4 kilowatts. So answer is a B is a correct. Very good. So now let us solve one more question. Question number 10. Neglecting the losses, the power transferred inductively is equal to the power transferred conductively in an auto transformer. Then the secondary to the primary ratio. Then the secondary to primary ratio of transformer. Neglecting the transformer, if power transferred inductively is equal to, so that means induction power, given that induction power is equal to conduction power. Conduction power. So induction power you can write 1 minus k times of the input power. Input power. So now this is equal to the here k times of the input power. Okay, got it? So now this is the input is the cancelled out. So 1 minus k into k. So now it is equal to 1 by the 2, 1 equal to 2k. So where k is equal to 1 by 2. So what is the answer here? K is equal to, K is we have to find secondary to turns ratio is a primary to the secondary. Here turns ratio in the sense, turns ratio that is the primary to secondary, right? And transformation ratio in the sense, okay, it is the secondary to the primary only. So it is the K value we have to find out. What is the K is equal to? 0.5. Okay, all of it clear now? Neglecting the losses, if power is transferred inductively is equal to the power transferred conductively. Gayatri, 2.4 is not correct. Yeah. Is it previous question? Okay, in the previous question, 2.4 is the correct. Okay, I think you have solved previous question, 2.4. Okay, that's correct. Okay, last question, 9th question ku 2.4 kilowatts, that's correct. 10th question ku 0.5. Okay. So now let us move on another question. So now can you solve this question, question number 11? First మనం అన్ని ఐఏఎస్ క్వశ్చన్స్ డిస్కస్ చేస్తున్నాం. కంప్లీట్ ఐఏఎస్ క్వశ్చన్ తర్వాత గేట్ క్వశ్చన్ డిస్కస్ చేస్తాం. ఓకే, దిస్ వాస్ గివెన్ ఐఏఎస్ 2010. Auto transformer, power is transferred through conduction process, induction process, and as well as the conduction and induction process. Okay, so in auto transformer, so that is the input power is equal to input power. So it is a induction power plus conduction power. Okay, induction power అనేది electrical isolated part of the winding. Power transferred through electrical isolated part of winding. బై మ్యూచువల్ ఇండక్షన్ ప్రాసెస్. ఒక నువ్వు 2 వైండింగ్ ట్రాన్స్ఫార్మర్స్ లో పవర్ ఎలా అయితే ట్రాన్స్ఫర్ చేస్తామో అదే ఎలక్ట్రికల్ ఐసోలేటెడ్ పార్ట్ ఆఫ్ ద వైండింగ్ ద్వారా పవర్ ట్రాన్స్ఫర్ చేస్తే దాన్ని ఇండక్షన్ పవర్ అంటారు. కండక్షన్ పవర్ అనేది ఎలక్ట్రికల్ గా కనెక్ట్ అయిన వైండింగ్ ద్వారా ప్రాసెస్ చేస్తే, అంటే 2 కండక్టర్స్ ఎలక్ట్రికల్ గా కండక్ట్ అయినా అనుకోండి, పవర్ ట్రాన్స్ఫర్ అయ్యేదాన్ని కండక్షన్ పవర్ అంటాం. సో ఎలక్ట్రికల్ కనెక్షన్ ఉండదు కానీ మ్యాగ్నెటికలీ కపుల్ ఉంటాయి కదా, ఆ పవర్ ఏమంటామంటే ఇండక్షన్ పవర్ అంటాం. సో దట్ ఎలక్ట్రికలీ ద కనెక్టెడ్ పార్ట్ ఆఫ్ ద వైండింగ్, part of winding. Okay, yes, so that both conduction as well as a induction process. Now let's move on another question. Okay, this is the question number 12. It is advisable to use the transformer if the transformation ratio is. Now this also one of the previous gate question. The advisable to use the auto transformer with the transformation ratio. Option A greater than the 1, nearer to the 1. Okay, is the 0.25, 0.5. What is the answer? Already I mentioned that. So here is a, in order to get the more advantages in auto transformer. Okay, here in order to get more advantages in auto transformer as compared to the 2 winding transformer, okay, K should be nearer to the 1. Should be nearer to the 1. So but here the range of the K here, range of K in auto transformer, so K is greater than the 0.33%, 33% and less than the 1. But here advisable or desirable value here, desirable value of K, value of the K. So now this desirable is a nearer to the 1. Nearer to 1, that is a K is a less than the 1 but nearer to the 1 only. So next one, the economically, here this is the one of the question. Economically the K is equal to always 0.5. Suppose nu a problem lo kuda K అనేది మనకు మెన్షన్ చేయకపోతే నువ్వు ఎకనామికల్ కండిషన్స్ లో మీరు K వాల్యూ 0.5 అనేది తీసుకోవాలి. నువ్వు అలా కాకుండా నియర్ టు ద 1 అనే మన ఏ వాల్యూ నియర్ గా ఉన్నాయి మనం మెన్షన్ చేయలేదు. సో దట్స్ వై వీ హ్యావ్ టు టేక్ ద K విచ్ ఈస్ ద ఎకనామికల్ పాయింట్ ఆఫ్ వ్యూ. Very good. So it is the nearer to the 1. So now can is another one. Let us solve question number 13. A 2 winding 220 upon 110 volts 1.5 kVA transformer is reconnected as an 220 upon 330 volts. The transformer it is re-rated as. Now okay, first చెప్పండి ఇది, is it a series additive polarity of auto transformer, subtractive polarity of auto transformer? Okay, we can find out very easy. Okay, from the rating of auto transformer, we can get easily. So that is the K is equal to the LV of auto transformer divided by HV of auto transformer. Okay, auto transformer. So now this value is equal to the 220 upon 330. Okay, 330. Okay, so by using the K also we can get, suppose I mentioned already, this is a method 1. Okay, method 1. So now here this is by using the K we can get this method. So now let us find out kVA rating of auto transformer is equal to the 1 by 1 minus K times of the kVA rating of the 2 winding transformers. Okay, here. So now let us find out 1 by 1 minus the here this k is equal to 220 upon 330 that multiplied by 15k 1.5 kVA. Okay, now calculate, you will get an answer. What is the answer here? So 4.488 kVA. Okay, like this also we can get, and other way also we can find out by using the circuit also. So this is the method 1. Like, so now let us find out method 2 also. Method 2, okay, by seeing this, it is the input voltage and output voltage V1 and so windings are connected. If the two windings of the transformer connected here, okay, if two windings are if the HV winding and LV winding of two winding transformer is connected in series additive polarity connection. Then the voltage rating would be 220 upon 330 volts. Got it, fine? So supply is given to the 220 volt side and high voltage, and then only it is a 220 upon 330. Otherwise it is not possible. Okay, so that's why we can write like this also. So here is a winding connection. Okay, it is a 220 volts. Okay, HV winding, it is a 220 EHV, and LV winding is connected in series. Okay, like so both are here. This is a, so like just assume it is a dot and it is a dotted here. So this is the both are connected in the series R2 polarity nature. So now this voltage is given, voltage V1 is equal to, so what is the value of V1? 220 volts. So here is the 120, 110. So it is the 110 volts. So that's why we will get V2 value is equal to here. The V2 is equal to 220 volts. So both are connected in the series. This one is the 220 and this is equal to 330 volts. We got 330 volts here. Now what about this current? How much amount of current flows here? So this is the current flows in the LV winding, the ILV here. So now I2 is equal to ILV value. How do we get this current? So current is equal to ILV here. So where ILV is equal to ILV. So that is the VA rating of the two winding transformer divided by the ELV. Okay, VLV value. So VA rating is given. So this value is equal to VA rating 1.5 kVA. So 1.5 into 10 to the power of 3 divided by ELV is equal to 110 volts. So now we required, okay, this ILV. So therefore I2 is equal to ILV is equal to, so 1.5 times of the 10 to the power of 3 into 110 volts. But we required kVA. How do we get kVA rating of auto transformer? kVA rating of auto transformer. So that is equal to the, in terms of the secondary parameters, V2 multiplied by I2. So V2 is the 330, the multiplied by 1.5 into 10 to the power of 3. So divided by 110. Okay, this is equal to the 3 times of the 1.5, that is equal to 4.5 times of the kVA. Okay, like this you can answer. You can answer by using the two methods. By using the circuit also we can answer, or by using the transformation ratio. Okay, got it. So let's move on another question. So this was given IS 2011, question number 12. A 2 volts upon 1 volts 2 winding transformer is connected as an auto transformer. Okay, its regulation as auto transformer compared to the 2 winding transformers. Its regulation compared to the 2 winding transformers. Now, what is the answer? This is not a year rating of the 2 winding. These are rating of 2 winding transformer. Rating of the 2 winding transformer. What is the answer? So rating of 2 winding transformer is equal to given 2 volts upon 1 volts. So it is the EHV and ELV. Okay, EL. But we have to find out the K. But here not given whether it is connected in series I2 polarity connection or subtractive polarity connection. Got it point? So it is not mentioned anything. మనకి క్వశ్చన్ లో ఏమి కూడా మెన్షన్ చేయలేదు. ఒకవేళ ఇది సిరీస్ I2 పొలారిటీలో కనెక్ట్ అయిందా, ఒక సిరీస్ సబ్ట్రాక్టివ్ ఆటో ట్రాన్స్ఫార్మర్ కనెక్ట్ అవుందా, ఎలా అనేది మనకు క్వశ్చన్లో అయితే ఇవ్వలేదు. సో ఇలా ఇవ్వలేనప్పుడు మనం ఏం చేయాలా, కే అనే వాళ్ళు ఏది తీసుకోవాలి, k is equal to, if it is not given anything about the k, consider k is equal to 0.5. Economically the k is equal to, here the economically the k is equal to 0.5. Economically k is equal to 0.5. okay, so now if k is equal to 0.5, what is the percentage voltage regulation? Percentage voltage regulation of, ఆల్రెడీ ఈ ఫార్ములా నేను లాస్ట్ క్లాస్లో డిస్కస్ చేశాను. మీకు ఒకవేళ డౌట్ ఉంటే ఆ క్లాస్ ఒకసారి వెరిఫై చేయండి. 1 minus k times of percentage voltage regulation of auto transformer is equal to 1 minus k times of the voltage regulation of 2 winding transformers. Yes, so that it is equal to 1 by 2. It is a less than, voltage regulation is a less, but it is the ratio also we can get. So మీకు ఈ డెరివేషన్ నేను లాస్ట్ క్లాస్లో డిస్కస్ చేసిన. మీకు ఒకవేళ డౌట్ ఉంటే ఆ క్లాస్ ఒకసారి వెరిఫై చేయండి. లెక్చర్ నెంబర్ 41. ఒక లెక్చర్ నెంబర్ 41 మీరు డిస్కస్ చేసి చూస్తే ఆ క్లాస్లో voltage regulation is equal to 1 minus k times of the year. K is equal to 1 by 2. So into voltage regulation of 2 winding transformer. Okay, now this is equal to how much? The 2 times, sorry, 1 by 2 times 0.5, 1 by 2. So that is a 0.5 into voltage regulation of 2 winding transformers. So that answer is a, what is the answer? The 0.5 times. నీకు ఇక్కడ ఈ ట్రాన్స్ఫార్మర్ ఎలా కనెక్టింగ్ అయిందని మనకు చెప్పలేదు. సో 0.5 times is the correct. So next question number 13. The ratio of primary divided by secondary voltage is a 2:1. Primary voltage divided by secondary voltage is the 2:1. Okay, the saving in terms of the weight of the copper required if an auto transformer used instead of the two winding transformer. Saving of the copper. Saving of copper material. Actually, weight of the copper is equal to weight of copper in auto transformer is equal to weight, that is a 1 minus k times of the weight of the copper in two winding transformer. But here question is about the saving of the copper, not weight of the copper in the auto transformer. So saving of the copper is equal to saving of copper, that is equal to copper material. So that is the weight of the copper, weight of copper in two winding transformer, the is equal to minus the weight of the copper in auto transformer here. So this is a, we can write weight of the copper in the, sorry, it is a two winding transformer, weight of the copper in the auto transformer. So that is the weight of copper in the two winding transformer is minus of 1 minus k times of the weight of the copper in two winding transformer. Okay, so this is the equation 1 and equation 2. Let us write saving of the copper. So therefore we can write the k times of the, okay, k times of weight of the copper, weight of copper material in case of the two winding transformer. So enta k value save చేసేది ఎంత ఉంటాయి చెప్పండి, k. సో k అనేది ఎప్పుడు కూడా లో వోల్టేజ్ బై హై వోల్టేజ్. సో ఆర్ సెకండరీ టు ద ప్రైమరీ. here k is equal to here 1/2, ఒక లో వోల్టేజ్ బై హై వోల్టేజ్. సో 1/2 into the weight of the copper in the two winding transformers. Okay, 1/2 in the sense how much percentage? The 50% of weight of, or otherwise we can write in terms of the per unit value 0.5 times of the weight of the copper in two winding transformer. Okay, so now percentage value ela calculate chestam. So percentage value is equal to always per unit value into 100. So per unit value enta 0.5 kada. So now multiplied by 100, so it is equal to 50%. Okay, ila calculate cheste meeku vachestadi. Next one. So another IES question. This was given IES 2015. A 240 upon 200 volts to 12 kVA auto transformer has 96.2% efficiency at full load and unity power factors. The full load efficiency at 0.8 power factor lagging when connected to an load across the 360 volts would be. So what is the answer? How do we get 240 volts, 110 volts, 12 kVA auto transformer has 96.2% efficiency at full load and unity power factors. Okay, the full load efficiency at 0.8 power factor lagging when connected to a load across the 360 volts. So now by using this you can find out the rating here 96.2. Okay, 96.28 full load efficiency. So what is the formula here? Percentage efficiency of transformer. What is the formula? So that is equal to, okay, here VA rating into, okay, this is the X into VA rating cos theta 2 divided by the X into S cos theta 2, okay, plus X square. The here let us write it is the total losses, complete total losses multiplied by 100. So actually this is it is not auto transformer, it is a only two winding transformer. I think it is a printing mistake. A 220 240 upon 110 volts 12 kVA transformer has 96.2% efficiency at full load and unity power factor. Now it is connected to an auto transformer with terminal voltage of the 360 volts. Okay, the here input is the same but low terminal voltage is 360 volts. So it is connected to the series R2 polarity connection. Then what is the here full load efficiency at 0.8 power factor lagging. So this is our answer. Like this we have, it is not an auto transformer, it is a two winding transformer. Okay, so now how do we get here? Losses I mentioned, percentage losses different, but losses of the auto transformer is equal to, let us find out here. So what is that? 96.02%. So now it is equal to 0.962. The equal to X is equal to 1. The rating is equal to 12. Okay, 12 kVA. So we can losses are in the kilowatts I have taken. That's why I have taken the 12 directly. Power factor is equal to how much? So 1, okay, divided by, so 1 into 12 into 1. So plus total losses. Okay, this is the total losses. Okay, losses of, so which transformer? Two winding transformer. So no need to multiply here. So therefore you can write total loss of two winding transformer is equal to, how do we get total loss of the two winding transformer here? So this is the 12 divided by 0.962 minus 12. So now simplify, you will get the total loss of the two winding transformer. Okay, no need to hurry, calculate very clear manner. First to there is a understand the problem, then try to solve the question. Okay, 12 divided by 0.962. So is equal to 12.47 minus 12. Okay, it is equal to 0.474 kilowatts. So these are the losses of the two winding transformer. But what about the losses, total loss of the auto transformer? Total loss of auto transformer. So that is equal to total losses of two winding transformer. So that is equal to 0.474 okay, kilowatts. But percentage losses are different, but we don't want to find percentage losses. So very important this one. Why? Because only connections are changing, but not the core and these windings are remain same. మీరు లాస్ట్ క్లాస్ ఒకసారి మీరు చూస్తే తెలుస్తుంది, నేను కోర్ను కానీ కాపర్ వైండింగ్స్ కానీ చేంజ్ చేయకుండా ఓన్లీ నేను ఎల్వి వైండింగ్ టెర్మినల్, హెచ్వి వైండింగ్ టెర్మినల్ కనెక్షన్ చేంజ్ చేసి ఆటో ట్రాన్స్ఫార్మర్ లాగా యాక్ట్ చేస్తుంది. సో అలా చేసినప్పుడు నీకు లాసెస్ సేమే ఉంటుంది, కానీ percentage copper losses will be changed. ఒక percentage losses will be changed. So that's why here, but kV rating is a different. Now kV rating of auto transformer is equal to auto transformer. So that is the 1 by 1 minus k times of the kV rating of the two winding transformer. Okay, so now this value is equal to 1 by 1 minus k enta low voltage by high voltage kada. So now ida k value ela calculate chestam. So that is the 240 divided by 360 volts. Okay, k of auto transformers. Okay, now this is the k calculate cheyandi. So that is the 240 divided by 360. So now multiplied by the kV rating, given kV rating is the 12 kVA. So now this value is equal to, what is the answer? 360. Okay, that is the 36 kVA, right? 1 by 3. So now here 36 kVA. 36 kVA. So now find out the efficiency of the auto transformer. Percentage efficiency of auto transformer is equal to, so now here the x times, okay, rating of auto transformer into power factor, okay, cos theta 2 divided by the x into s times of the auto transformer, the into cos theta 2, the plus, okay, total losses of the auto transformer. Okay, multiplied by 100. Now calculate, you will get a answer. Very important question. Gate lo kuda ilanti question okati undi. We will solve that question also today. Same problem but different values are given, but model is the same. Okay, now calculate. X value is given. What is the x? Here x is equal to power pack full load only. X is the 1. Power pack is the 0.85. So now this value is equal to, calculate. So x is the 1, s is the 36 kVA into 0.85 divided by 1 into 36 into 0.85. Okay, plus losses is the 0.474 kilowatts only, multiplied by 100. So now it is equal to how much? Calculate. Calculate yourself. I will also calculating. I'm also calculating about this. So నేను కూడా calculate చేస్తాను, మీరు కూడా calculate చేయండి. Let us compare each other. So now this is a 36 into 0.85. Okay, plus 0.474. Okay, 30.6 divided by answer. Okay, now 98.47. 98.47%. This is the answer. Okay, Gayatri, 98.47. Okay, like this we have to calculate. So 98.47 means which is very nearer to the 98.5. Okay, option C is a correct. Here don't take 1 minus k. Okay, this is the very important. మీరు ఇక్కడ 1 minus k calculate చేసిరు అనుకోండి, మీకు రాంగ్ ఆన్సర్ వస్తుంది. మీకు ఒకవేళ చాలా మిస్టేక్ అయ్యే ఛాన్స్ ఎక్కడంటే నువ్వు టోటల్ లాసెస్ తక్కువ కదా, ఎవ్రీబడి నోస్ లాసెస్ ఆఫ్ ఆటో ట్రాన్స్ఫర్ ఈజ్ లెస్ యాజ్ కంపేర్ టు ద ట్రూ వైండింగ్ ట్రాన్స్ఫర్ అని. కానీ లాసెస్ లెస్ కాదు, పర్సెంటేజ్ లాసెస్ ఆఫ్ ఆటో ట్రాన్స్ఫర్స్ ఆర్ లెస్ యాజ్ కంపేర్ టు ద పర్సెంటేజ్ లాసెస్ ఆఫ్ ద టూ వైండింగ్ ట్రాన్స్ఫర్. సో నౌ ఆ లాసెస్ ఎంత పర్సెంటేజ్ అంటే 1 - k. నువ్వు ఇయర్ టోటల్ లాసెస్ అనేది సేమే. ఈ పార్ట్ చాలా ఇంపార్టెంట్. ఓకే, టోటల్ లాసెస్ ఆఫ్ ఆటో ట్రాన్స్ఫార్మర్ ఈజ్ ఈక్వల్ టు ద టోటల్ లాసెస్ ఆఫ్ ద టూ వైండింగ్ ట్రాన్స్ఫార్మర్. రీజన్ ఈజర్ నువ్వు ద వైండింగ్స్ కానీ కోర్ కానీ సేమే ఉంటుంది. వైండింగ్స్ ఆర్ సేమ్, ఓకే, కోర్ ఈజ్ ఆల్సో సేమ్, బట్ ఓన్లీ connections are changing, okay, to get the auto transformer. Connections change, so that's why here losses remain same, but kVA rating అనేది చేంజ్ అవుతుంది కాబట్టి పర్సెంటేజ్ లాసెస్ కానీ పర్సెంటేజ్ రెసిస్టెన్స్ అవి చేంజ్ అవుతాయి. ఆర్ క్లియర్ నౌ? Okay, now let us discuss one more problem. So this is also previous question. A 25 kVA 2500 250 volts two winding transformer to be converted into auto transformer. Determine the kVA output capacity and voltage ratios of all possible connections. All possible connections. Okay, we have two possibilities. Okay, 4 possibilities are there, but let us find 2 possibilities. One is the series additive polarity connection and series subtractive polarity of connection. So now these are all possibility connection means, suppose I have taken this, the voltage is a one possibility is like the 2500. Suppose if I draw this circuit, okay, clear point. So this is the one possibility and this one is a another possibility connections. Okay, so now let us find out one by one. So what are the, let us find 2 possibilities. Suppose it is the HV winding. Okay, in case of this is the HV winding and it is the LV winding, these two are connected in the series R2 polarity manner. So then what will happen? It is the V1, okay, it is the V2. So V2 we will get, so how much value of the V2? So EHV plus, okay, EHV plus ELV value, okay, ELV. So now this is the V2 and V1 is equal to how much? So V1 we got, so 2500 volts, okay, 2500. So now what about the K value here? K is equal to, so low voltage, the 2500, the plus, okay, 250, so that is a 2750, okay, 750. So therefore we can write kVA rating of auto transformer the is equal to 1/1 - k times of the kVA rating of the two winding transformers. Okay, got it my point? So now let us find out 1/1 - k is a low voltage by high voltage. So 2500 divided by 2750, okay, into the 25 kVA, okay, 25 kVA. So now calculate, so this part into 25 kVA, so that your kVA rating of auto transformer is equal to, we have to find out kVA and ratio, voltage ratio. that is the K value. So it is equal to, so 2750 divided by 250. 2750 divided by 250. So now it is equal to 25. So now 5 times and 7 times, 7 into 25, it is equal to, okay, calculate this part. What is the answer? Okay, 2750 divided by 250. So we'll get 11 into 25, right? It is not 250 here, 25. Okay, that is the 275. 275. So now here, so this is a connected in the series subtractive polarity. Okay, like this we are connecting. So LV winding and HV winding. So it is a V1 and V2. So if windings are connected for, okay, for subtractive polarity, okay, subtractive polarity of auto transformer. So what will happen? So V2 is equal to EHV minus VLV. Okay, VHV minus VL. So that is the 2500 minus 250. So now it is equal to 2250 volts. That step down auto transformers. So now let us find out K here, transformation ratio. The KVA of auto transformer is equal to the 1 by the, it is a 1 minus low voltage is at 2250 divided by 2500. So multiplied by, okay, 25 kVA. So now simplify this, you will get a answer. So what is the answer here? 125 kVA. Okay, 125 kVA. So like this we have to calculate all possible connection, but some other possibles also there, but it's not required here. So this is the one per subtractive polarity and per additive polarity. Polarity of auto transformer. So now let us calculate one more question. So this was the gate 99 question. Now we will solve all the gate questions. A 400 upon 100 volts 10 kVA 2 winding gate transformer is reconnected as an auto transformer across the suitable voltage source. Maximum the rating of such an arrangement could be. Maximum rating of such an arrangement could be. What is the answer? Maximum rating of such arrangement could be. How do we get this answer? Here is a question is given. Suppose the 2 winding transformer data. 2 winding transformer. So that is a 400 upon 100 volts. Okay. The 10 kVA. Okay. So now this is a, okay, here this we can write here EHV value, EHV, and it is a ELV value. Okay, ELV. So now in the case 1, I have taken case 1. Case 1. Suppose case 1 here per series additive polarity connection. Let us make it as a series additive polarity connection. So now what will happen per series additive polarity connection? Additive polarity connection. Polarity connection. So therefore here K is equal to how much? So this is the suitable voltage source. K is equal to, so here low voltage by high voltage. So now K we can get the low voltage divided by high voltage. So per this low voltage is a 400. Okay, high voltage is a EHV plus ELV. So low voltage is our per series polarity connection. So now this is the 400 and 500, 4 by 5, 4 by 5 in the sense, what answer? 4 by 5, 0.9. Nearest value is 0.4 by 5. 4 divided by 5, that is equal to, so it is a 0.8. Okay, so next one, if it is connected, another case too. So for example, for series here supply is given. Okay, supply is a 400 volts. Okay, supply is a 400 volts. Okay, suppose if supply is of 200, this is the supply, then what will happen? See, we have to take all the possibilities. Suppose if the supply is the 400 volts, then K is equal to LV by, suppose if supply is the 100 volts, 100 volts, okay, then what is the K here? The K is equal to the LV by HV. Okay, L is the 100 divided by 500. So now it is equal to 1 by 5. 1 divided by 5. So that it is a 0.2. Okay, 0.2. So next case 2. Okay, now if supply is here connected here, case 2, for subtractive polarity. Polarity of auto transformer. Then what will happen? Okay, మన subtractive polarity దగ్గర కనెక్ట్ చేసినాం అనుకోండి, నీకు సప్లై ఇయర్ ఇఫ్ సప్లై 400 volts అనుకో, సప్లై ఇఫ్ సప్లై ఇస్ ఏ 400 volts, ఒక 400 volts. సో నువ్వు ఈ డిఫరెన్స్ ఆఫ్ దిస్ వోల్టేజ్ కదా, సో V2 ఏమవుతుంది? V2 కంపల్సరీ డిఫరెన్స్ ఆఫ్, సో EHV minus ELV. So now it is equal to, what is the value of VHV minus VLV? So now this value is equal to 400 minus 300 minus 100. So now it is equal to 300. So now let us find out K. Now K is equal to low voltage by high voltage. So 300 upon 400 volts. So now calculate this 300 divided by 400. Sorry. 300 divided by the 400, it is equal to 0.75. 0.75. సో నీకు ఇంకొక పాసిబిలిటీ కూడా ఉంది కదా, సప్లైని నేను 100 వోల్ట్ సప్లై 100 వోల్ట్ సైడ్ ఇచ్చి నువ్వు సిరీస్ సబ్ట్రాక్టివ్ పొలారిటీలో కనెక్ట్ చేస్తే V2 ఎంత అవుతుంది? సో VHV మైనస్ VLV కదా, VHV మైనస్ VLV. సో నౌ ఇట్ ఈస్ ఈక్వల్ టు హౌ మచ్? ద 400 మైనస్ 300. So now, sorry, 100, okay, it is equal to 300. So now calculate the K here. K is equal to, so low voltage by 100 divided by 300. Okay, it is equal to 0.3. So now, if the K is the nearer to the 1, then what will happen? Already I mentioned that. So in order to get the more advantages in the auto transformer, K should be nearer to the 1. That is the desirable value. Yes. Okay, in order to get more advantages in the auto transformer, K should be nearer to the 1. When K is nearer to the 1, then what will happen? Okay, so here in order to get more advantages in auto transformer, K should be nearer to the 1. Nearer to the 1. So therefore here which cases is the possible? So series additive connection, so that, so we have to select, therefore we have to choose this series additive polarity of auto transformer. of auto transformer with 400 volts as supply. 400 volts as a supply. So let us find out kVA rating of auto transformer is equal to 1 by 1 minus k times of the kVA rating of the two winding transformers. Okay, got it my point? So now let us calculate 1 by 1 minus k is equal to here 0.8. So multiplied by, so this is a, what is the value of k here? 10 kVA. Okay, 10 kVA. So now calculate this, you will get answer. So 0.2, so that is a 20. Now zero 0.8 1 divided by 0.2 into 10. So now answer is a 50 kVA. Okay, like this we have to calculate. Okay, ila calculate chal. So answer for this question is a 50 kVA. సో ఆల్ మన కే ఇవ్వలేదు కానీ సూటబుల్ వోల్టేజ్ సోర్స్ సెలెక్ట్ చేసుకోమన్నాడు. సో మనం ఎలా సెలెక్ట్ చేసుకోవాలా? ద కే ఇయర్ వీ హ్యావ్ టు సెలెక్ట్ ద ఆటో ట్రాన్స్ఫార్మర్ విచ్ ఈస్ వెరీ నియర్, కే వాల్యూ ఈజ్ నియర్ టు ద 1. Okay, all of you clear now? So now let us calculate one more question. So now this is I think it is the same question. So now calculate this. A 50 kVA 3300 230 volts single phase transformer is connected as an auto transformer shown in the figure. The nominal rating of auto transformer will be. So actually in the figure it was given like, okay, dotted also mentioned. This is the 2 dots. Okay, can you solve this? First to tell me, by seeing this circuit, is it a series to polarity connection or series subtractive polarity connection? Okay, here this is the positive, okay, this one is the negative, and this is the positive and this is the negative. So now here we have to get the V out. So now this voltage is the EHV, right? Okay, EHV, and this voltage it is a ELV. Okay, ELV1. So how do we get output voltage? So therefore here V output voltage is equal to the EHV plus ELV. Okay, because windings are connected in series to polarity. Windings are connected in series additive polarity. Additive polarity. Okay, got it? So that's why output voltage is equal to, so it is a 3300 plus 230 volts. So now it is the 3530 volts. Okay, 30 volts. Now let us find out K. The K is equal to, okay, how do we get the K? So K is equal to always low voltage of auto transformer divided by high voltage of the auto transformer. What is the low voltage of auto transformer? So here is a low voltage, this is the low voltage, and this is the high voltage of auto transformer. So 3300 divided by 3530. So now find out the K value. The kVA rating of auto transformer is equal to 1 by 1 minus K times of the kVA rating of the two winding transformer. So now simplify, you will get an answer. So that is the 1 by 1 minus 3300 upon 3530. Okay, here 1 by 1 minus 3300 upon, so 3030. Okay, so now this multiplied by, so what is the kVA rating? 50 kVA. So now calculate, you will get, so that is a 767.4 kVA. Like this you can answer. And other way also we can answer by using the circuit. Okay, we can answer another way also, I will tell you. See, so that is the second method. How do we answer this? By using the circuit also we can answer. So this is the, it was given, okay, V1, here V1 is equal to 3300 volts. So windings are connected in the series R2 polarity connection. So here is a dot and here also dot. So now this is a, if we don't know the what is the output voltage, the load terminal voltage, the V2. Okay, and it is a LV winding and this one is the HV winding. So that here current passes to the LV winding is a ILV and it is a current is a I2 current. So now this is equal to ILV only. Okay, so now here the V2 is equal to, when two are connected here, EHV the plus ELV value. So now let us find out. Already we got EHV plus EL. So it is equal to how much? EHV plus ELV. The 3300 plus 230. So divided, this is equal to 2500. 3530 volts. But what about how do we get ILV here? So now this ILV you can obtain. So kVA rating of, okay, VA rating of the two winding transformer. Okay, it is a two winding transformer divided by ELV. So now it is equal to 50 into 10 to the power of 3 divided by 230. So now let us find out kVA rating of the auto transformer is equal to the V2 multiplied by I2. So what is the V2 value? V2 is equal to, so 3530, the into I2 is equal to 50 into 10 to the power of 3 divided by the 230. So now it is equal to 767.4. 767.4 kVA. Like this also we can answer. In the two methods we can answer. Very, very important. Any problem also we can answer by using the transformation ratio as well as by using the circuit analysis. Whatever you feel easy, you can go through that method. Okay, now let us solve one more question. So this is another question based on this concept. Very good, Gayatri, that's correct. 767.4, that's correct. Nageshwar also you have given right answer. Now this is the another possibility question. Already we have solved this type of question in case of the IES problems. A single phase 50 kVA 250 volts upon 500 volts two winding transformer has an efficiency of the 95% at full load and unity power factor if it is reconnected as an auto transformer. So this is the rating of the auto transformer. Okay, it is given as a, so this is nothing but rating of auto transformer, so that you can find out the K easily. So okay, K is equal to low voltage of auto transformer divided by high voltage of the auto transformer. So now this value is equal to K here. So that is the low voltage is of 500 divided by 750. So now it is equal to 2 by 3. Okay, that is the K. So that K is over. But efficiency here, it reconnected as an auto transformer, it efficiency. So I already mentioned, if it is a reconnected as an auto transformer, losses remain same, total losses remain same, but kVA rating will be the different. Okay, now calculate here. So therefore we know efficiency of the transformer. We know percentage efficiency of transformer. So that is equal to the X into S two winding transformer. Okay, that is the S is a, so S cos theta 2 divided by X S cos theta 2, the plus, okay, here the this is a total losses, okay, multiplied by 100 here. So this is the generalized equation. So now let us substitute all the values in this equation. So percentage efficiency of transformer. So this was given in the question. So now it is equal to how much? 0.95%. So that is the 0.95. Now X is equal to 1 and S is equal to 50 kVA. Okay, next one, cos theta is equal to unity power factor 1. Okay, now here 50 plus total losses. We don't know the total loss. So we have to calculate this total loss of the two winding transformer multiplied by, so no need to multiply here. Already I have taken 0.95. So now therefore here total loss of two winding transformer is equal to 50 divided by 0.95 minus 50. Now calculate this. 2.631 kilowatts, right? 2.631 kilowatts. Okay, it is the total loss of the two winding transformer. But what about losses of the auto transformer? We have to find out efficiency of auto transformer. So losses of auto transformer, that is the total loss of auto transformer, it is equal to the total losses of two winding transformer. So that is equal to how much? 2.631 kilowatts. 631 kilowatts. Okay. (2.631 kilowatts). Now calculate what about the kVA rating? kVA rating is not same. kVA rating is a different. kVA rating of auto transformer is equal to 1 by 1 minus K times of the kVA rating of the two winding transformers. Okay. So now K already we have calculated. K is equal to 1 by 2 by 3. Okay, into the 50 kVA. Now this one. So this the 2 by 3 means here 3 times of it is equal to 150 kVA. All of you clear now? 150 into 50 kVA. Okay, what's the answer? So now after getting the kVA, now find out percentage efficiency of auto transformer is equal to, so that is a x into s cos theta 2 divided by x into s cos theta 2, okay, plus total losses of auto transformer, total loss of auto transformer multiplied by 100. So now this is equal to how much? X value here given that efficiency is new rated load at unity power factor. Okay, new rated load at unity power factors. So now therefore 1 into 150 into 1 divided by 150 plus 2.631 kilowatts. So multiplied by 100. Now calculate now. Now Ishwar, now tell me the answer. %. Okay, now see the what are the options are given. 98.276%. So option C is the correct. Like this we have to calculate. Okay, Gayatri, you got it? Same answer వచ్చిందా? Okay, now let's move on to the another problem. Okay, now calculate. This was GATE 2014 question. A single phase 50 kVA 1000 volts upon 100 volts two winding transformer is connected as an auto transformer as shown in the figure. So then find out kVA rating of auto transformer. This was a very easy problem. Calculate. This is the GATE 2014 question. Here voltage is given, it is 100 volts, so this is the series R2 polarity connection. Okay, the voltage V1 and V2 are given, so therefore here we can find out K value, the K of auto transformer, so that is equal to LV of auto transformer divided by HV of the auto transformer. So LV is equal to 1000 divided by 1100. Okay, 1000 divided by the 1100 volts. So now it is equal to, okay, 10 by 11. Now calculate kVA rating of auto transformer is equal to 1 by 1 minus K times of the kVA rating of the two winding transformer. So now it is equal to 1 by 1 minus 10 by 11 into 50 kVA. So now calculate this value. 550, 11 minus 1, and is a 550. kVA. So that's correct. It is a fill in the blank question. 550 kVA. Okay. So now calculate one more question. So this was GATE 2015 question. GATE 2015 question. A 200 upon 400 volts 50 hertz two winding transformer is rated at 50 kVA, right? Rated at the 50 kVA. This is the two winding transformer. It is winding are connected as an auto transformer. Winding is connected as an auto transformer of rating of 200 upon 600 volts. Okay, this is the rating of the auto transformer. A resistive load is connected. Okay, this that resistive load is connected to an high voltage side. Okay, that is the 600 volt side is connected. So the value of the equivalent load resistance as seen from the LV side. As seen from the LV side. First draw the equivalent circuit. Then only we can answer this question. So initially it is a 200 volts. Okay, this the LV winding. LV winding here. And this is the okay, it is a LV winding is a supply is given to the LV winding. So these are connected in the series additive polarity connection. Okay, additive polarity connections. So this is the common point between the source and load. So this one is a here. Okay, it is a supply voltage V1. And these two are connected to the load terminals. Okay, it is a the load connected to the V2 terminals. Am I right? So this is the V2. So it is a EHV and here ELV, and this is the current passes through in this case I2 current. So this I2 is equal to the IHV value IHV. Okay, and here current here I1. So how to get I1 current? So this I1 current is the both are connected in the series R2 polarity. So that's why it is a ILV plus IHV value. Okay. So now this load is mentioned here. Actually, here resistive load is given. So this is the resistive load given that. So now what is the value of the resistive load? It is at 2 ohms. Okay. So now what is the resistance seen from this side? Okay, it is a I2 and here I1. Now transfer the resistance from the secondary circuit to the primary circuit. How do we transfer the resistance from the secondary circuit to the primary circuit? So this voltage is equal to how much? Okay, here this value is equal to, sorry, it is a 400 volts. Okay, this one is a 200 volts. Okay, now here also 200 and okay, this is the 600 volts. Okay, like this we can answer here. Now the value of the equivalent load resistance in ohm as seen from the LV side. Okay, as seen from the LV side. Now calculate this by using two methods we can calculate. So one is a by the power balanced equation and other one is a by transferring the resistance from LV side to the HV side. Okay, power balanced equation and LV side to HV side of the transformers. First try yourself. I will tell you that part. Okay, we got it now. So let's calculate first. Okay, that is a 600. K is a 0.03. First, what is the transformation ratio? Okay, here this value is equal to, here is the 200, right? Okay, 200. So now here transformation ratio, okay, that is equal to N2 by N1. So it is equal transformation ratio of auto transformer. Okay, it is equal to N2 by N1. So our V2 by V1. So now we can write 600 divided by, so it is a 200. So 600 divided by the 200, it is equal to 3. So now after transferring this resistance, okay, resistance refer to the LV side. Resistance, here is a resistance refer to LV side. So now it is equal to, so this is a R2 dash. Okay, here R2 dash. So now it is R2 dash means R2 by K square. So R2 by K square here. So here don't confuse. This is not a K value. Okay, here is a, so we just like we are calculating as like a two winding transformer. Transformation ratio N2 by N1. Turns ratio here A. So that is a N1 by N2. So that is a R2 is a 12. Okay, this one is a K square is a 3 square. Okay, it is equal to the 12 by 9. So it is the answer. So 12 by 9 in the sense that it is equal to 4 by 3. 4 by 3 means what? What is the answer? 4 by 3. 2 point. Can you calculate 4 by 3? Four by 3. 4 divided by 3, that is equal to 1.33. This is the answer for this question. Okay. Now, can you solve one more question? There is another question here. So this was given GATE 2016. Let us complete 2 or 3 questions are there. So let us complete first. Are you getting bored? Naheshwar, Gayatri, Pavan, are you getting bored in the class? Yes, that's correct. 1.33 correct. బోర్గా ఫీల్ అవుతుర్రా క్లాస్లో? ఓకే, థ్యాంక్ యూ. బోర్గా ఫీల్ అయితే చెప్పండి, క్లోజ్ చేసేద్దాం క్లాస్. A single phase 22 kVA 2200 volts 220 volts 50 Hz distribution transformer is to be connected as an auto transformer. Okay, is to be connected as an auto transformer to get the output voltage of the 2420 volts. So its maximum kVA rating, it's very easy. Okay, just K is equal to the K of auto transformers. So find here, this is the to output voltage is given, so that V1 of auto transformer is equal to 2200 volts V2 of auto transformer. This is the input voltage and this is the output voltage. So therefore it is equal to 2420. So transformers are connected here. So this is the connected in the series additive polarity connection. Additive polarity connection. So that's why we can write K is equal to here LV of auto transformer divided by the HV of the auto transformer. What is the value of LV of auto transformer here? LV of auto transformer, that is a 2200 divided by 2420. So now find out KVA rating. KVA of auto transformer is equal to 1 by 1 minus K times of KVA of the 2 winding transformer. Now calculate 1 by 1 minus K is equal to 2200 upon 2420. So multiplied by the KVA is the 22 KVA. Okay, now calculate. Okay, ila calculate chesin tarvata. So 242 KVA. 242 KVA. So this is a 220 by 240 here. That is a 20. That is a 242 KVA. 242 KVA. Very good. Okay, next. Let us solve one more question. This was given GATE 2016. A single phase 2 kVA 100 upon 200 volts transformer is reconnected as an auto transformer such that its kVA rating is maximum. The new rating in kVA is. Okay, now here all possibility lo K value find out cheyandi first. Okay, KVA rating maximum undala కానీ ఎన్ని పాసిబిలిటీ ఉంటుంది? నువ్వు సిరీస్ అడిటివ్ కనెక్షన్ లో 2 పాసిబిలిటీస్ ఉంటాయి. సో సిరీస్ సబ్ట్రాక్టివ్ కనెక్షన్ లో కూడా 2 పాసిబిలిటీస్ ఉంటుంది. కానీ మనకి K మీన్స్ ఎలా మీన్స్ హియర్ సింగిల్ ఫేజ్ ఇది 2 వైండింగ్ ట్రాన్స్ఫార్మర్. ఓకే, 4 పాసిబిలిటీస్ లో ఓకే ఆ పాసిబిలిటీ చెక్ చేసి ఫైండ్ అవుట్ చేయాలి. నీకు ఫస్ట్ వన్ అజ్యూమ్ హియర్ కేస్ 1. సో when here is a assume windings are connected in series additive polarity. Here. Okay, let us assume these the windings are connected in series additive polarity. So if supply voltage, okay, if the V1 is equal to 100, V1 is equal to 200 volts I have taken. Okay, this is the VHV, here VLV, okay, VLV, and this one is the EHV. Okay, the VHV of the 2 So here I have taken if supply voltage is equal to 200 volts. So then the what will happen V2 here, the V2 is equal to both are connected here VHV plus the ELV. So that is equal to the 200 plus 100 that is equal to 300 volts. Now calculate K value here. So K is equal to LV of auto transformer divided by HV of the auto transformer. Okay. So let us calculate here. So therefore K is equal to LV of auto transformer. What is the LV here? So LV is a 200 upon 300. Okay, 2 by 3. So 2 by 3 value is equal to how much? So this is equal to 2 divided by 3, that is a 0.66. 0.66. Okay, this is the value of the K. So next one, if V1 is equal to 100 volts. Okay, there is a possibility, but windings are connected in series. So then the V2 is equal to, so VHV plus V100, that is equal to 300 volts. So then the here let us calculate K. The K is equal to low voltage by high voltage. What is the value of low voltage here? 100. So now it is a 100 divided by 300. So it is equal to 1 by 3. So that it is a 0.33. So now next one, case 2. Case 2. Assume windings are connected. Windings are connected in series subtractive polarity. Subtractive polarity here. Then what will happen? Okay. So if windings are connected in series subtractive polarity, let us assume if V1 is equal to 200 volts. So then the what will happen in the V2? The V2 is equal to EHV plus ELV, right? So now calculate VHV plus VLV. So now this is equal to 300 volts. Sorry, series subtractive polarity. That's why it is a EHV minus ELV. VHV minus ELV, 300 minus. So now it is not the 200 minus 100. So now it is equal to 100. So now what about the here? K is equal to low voltage of auto transformer divided by HV of the auto transformer. So now this is equal to low is 100 divided by 200. So it is equal to 0.5. Okay. So now calculate another one. So if V is equal to here if the V1 is equal to 100 volts. So then the V2 is equal to how much? V2 will become the 100. So now here, so this value is equal to 200 minus 100. So now it is equal to K here. So this the K is equal to 1. So it is not possible actually. So K is always less than the 1. So that's why. So this connection is not correct. So now which one is a new KVA rating in auto transformer? K is always K of auto transformer always less than the 1, not equal to the 1, less than the 0.33. Okay, that's why we cannot take this one. So now after this, which is the highest value here? K is a 0.6. So here windings are connected in series to polarity. The polarity of auto transformer, the with supply voltage is at 200 volts. Okay. Windings are therefore windings of two winding transformer are connected in series additive polarity nature. Additive polarity nature, polarity, and excited with the rated high voltage. Okay, that means V1 is equal to 200 volts. So when V1 is equal to 200 volts, K is equal to how much? So K is a 200 divided by 300. So now it is equal to 200 by 1, that is a 0.66. So now calculate here the KVA rating of auto transformer. KVA rating of auto transformer. So that is a 1 by 1 minus K times of, calculate yourself. Okay, now calculate this part. Okay, 6 kVA, right? That's correct. So it is a kVA rating of auto transformer is equal to the 1 by 1 minus k times of the kVA rating of the 2 winding transformer. So it is equal to 1 by 1 minus 0.66 the into the 2 kVA. So now it is equal to 6 kVA. Okay, so this is the answer for this question. So now this was another previous gate question. It is a linked answer question. The figure above shows coils 1 and 2 with dot marking as shown in the figure, having the 200 and 600 turns respectively. Both coils have rated at the 25 amps. Coil 1 is excited with the pace of the single phase 400 volts. So now this is the number of this voltage is excited with the 400 volts, right? And this one is a number of turns here given 4000 volts, 4000 and 6000. So now that's why it is you will get the this is the 600 volts. So here is it is a ELV, and this one is a it is EHV of the 2 winding transformer. So now the coils are to be connected to obtain this transformer. Okay, this is the auto transformer rating. So to drive a load of the 10 kVA, how do we connect here? 400 is a supply, and this one is the V1 and the V2. So V1 is a 400 and V2 is a 2. This one is a 1000 volts. So to get, how do we connect? So this is the A terminal. Okay, A and B terminals. So now this is the A and this one is the B, but A is a dotted with respect to the B. So next one, and C and D. Okay, here is a. So if it is connected here, D is a C is a dot and D is undotted. So now that's why this is connected like. So it is a C terminal and D terminal. The C is a dotted. So this is the connection point of view. So now supply is given to this terminal. It is excited with the 400 volts. Okay. Now this is the sub terminal voltage. Okay. Enta load voltage untundi V2 here. So V2 is this one is the 600 volts. Okay. It is a 600 volts means. So this is equal to HV, right? The HV winding, and this is the LV winding. So now here current is a I2 and this current is a I1. Okay. So now rating also given. Rating of auto transformer. kVA rating of auto transformer. So that is equal to 10 kVA is given. So that by using this rating you can find out I1 and I2. But we required current in the LV winding. So it is a coil 2, coil 2 here, and this one is the coil 1, coil 1. So V2 is equal to 400 plus this is the 600, it is equal to 1000 volts. So but here, so what is the answer for this question? Okay, A and this common point is a B, right? A and D are connected, common is a B. So that this is the correct. A and D are connected, so common point is a B. So next, same question, but there is a same data and another question. Okay, this is the sixth question, see, and the second question here, and this one is the first question. Okay, data is remain same. Now, how do we answer this one? In the auto transformer obtained in the question number 1, so the current in the each coil is current in the each coil. Coil 1 current and coil. We have to find out the current in the HV winding and LV winding, not the input current of auto transformer and output current of auto transformer. How do we get input current of auto transformer here? The input current of auto transformer, so that is the I1. Okay, it is equal to, so here the rating, kVA rating of, okay, auto transformer divided by V1. So now it is equal to 10 into 10 to the power of 3 divided by 400 volts. So that it is equal to how much? 25 amps. Now output current of auto transformer, so that is I2. So how do we get I2 here? kVA rating of auto transformer divided by V2. So now here 10 into 10 to the power of 3 divided by 4 divided by this is the 1000. So now it is equal to 10 amps of the current. But we required current flows in the coil to coil 1. Okay, coil 1. So now let's find out by using this figure. So this is the HV winding, right? Okay, here HV winding. HV winding means it is a coil 2. Okay. LV winding means it is a coil 1. The current flows in the coil 2. So that is the current in the HV winding. So that is equal to I2. Okay. So therefore here current in coil 2. Coil 2 is equal to current in the HV winding. So that is equal to I2. Okay. It is equal to 10 amps of the current. Okay. So next one, current in the coil 1. How do we get current in the coil 1? So this current is required. So here we know these two. Okay, we can obtain from the rating of the given auto transformer. But how do we get this coil 1? So we know that I1 is equal to, whenever these two are connected in series or two polarity connection, I1 is equal to IHV plus ILV values. Okay, I1 is equal to IHV plus IL. So now let us calculate. So current in coil 1, current in coil 1, how do we get? ILV. Okay, ILV values. So now this is a, we know here. So we know I1 is equal to ILV plus IHV. IHV already we got. So therefore ILV is equal to I1 minus IHV. So now it is equal to 25 minus 10. It is a 15 amps. So current flows in the coil 1 is a 15 amps. Current flows in the coil 2 is a 10 amps. Coil 1 is a 15. Coil 2 is a 10. So that this is the answer for this question. Okay. So now this is another question based on this concept. Let's solve this question. A saving of copper in auto transformer will significant over two winding transformer of the same rating when the ratios of the voltage is equal to 1, less, very less than the 1, very greater than the 1, or nearly equal to 1. What is the answer? The desirable value here, this option is nothing but very greater than 1. So here very greater than the 1 is not correct, and this is the equal to 1 is also not correct. So now very less than the 1, very less than 1. So now it is also correct. It's not correct. So range of the K is, already we have discussed range of K. Okay, that is a K is a less than the 1 and greater than the 0.33. Okay, this is the range of the K. But here to get more advantage, in auto transformer as compared to as compared to two winding transformer. The two winding transformer, K should be nearly equal to 1. K should be nearly equal to 1. Equal to 1. So that answer for this question is option A is the correct. Very good. That's correct. Next one. Let us solve this question. Another possibility of the question based on this concept. Okay, it's a 100 volts 58 single phase supply is needed from the 200 volts 58 source. The ratio of weight of the copper needed for the two winding transformer as compared to the auto transformer. So ratios we required. The ratio of weight of the copper needed per two winding transformer, and here is a and auto transformer employed for the purpose. So now actually here the weight of the copper in auto transformer divided by weight of copper in two winding transformer. So it is equal to 1 minus K. Okay, but your question is asking the ratio of weight of the copper in the two winding transformer by weight of the copper. In the reverse manner is the question. So that's why here weight of the copper in two winding transformer divided by weight of the copper in auto transformer. So that is equal to 1 by 1 minus K. So now where K is equal to how much? K. Low voltage by high voltage. Okay, K is equal to 0.5. So now it is equal to 1 by 1 minus, now it is a low voltage 110 by, okay, it is equal to 220. Okay, so now this ratio is equal to 2. 1 by 2. So now K is equal to 1 by 2. So that's value is equal to the 2. So answer for this question is option A is the correct. Ratio of weights of the copper needed in the two winding transformer and auto transformer. But actually here we know this part. Okay, we know that weight of the copper in auto transformer is equal to weight of the copper in the two winding transformer, that is the 1 minus K. But here asking, so in the question is given weight of the copper in the two winding transformer by weight of the copper in the auto transformer. So have we got it now? 2. That's correct. So now let us solve this question. Another possibility question based on this concept. A 22 kVA 110 volts 220 50 Hz transformer is connected in such a way that it steps off 330 volts from the 120 maximum kVA. You can easy problem, you can answer this question. So first find out the K. Windings are connected in series additive polarity connection. Additive polarity nature. So therefore K is equal to LV of auto transformer divided by HV of the auto transformer. What is the LV of auto transformer? 110. And HV of auto transformer is equal to 330. So now it is equal to 1 by 3. Very good. So 1 by 3. So next one, find out kVA of auto transformer, so is equal to 1 by 1 minus k times of the kVA of the two winding transformer. So now it is equal to 1 by 1 minus k. The k is equal to 1 by 3. The into kVA is equal to 22 kVA. So now simplify, you will get what is the answer? 1 by 3 means it is a 1 by 3, the 2 by 3, 3 by 2, 1.5. 1.5 means 22 plus 33 kVA. .5 into 22. Okay, that is equal to 33 kVA. Now solve this question. This is the last question we will discuss. So another question I will give our homework. The two winding transformer and the auto transformer circuit as shown in the figure are ideal. Okay, that is that there is no resistance drop here. The current in the section BC. Okay, here current in the section. Okay, this current is the required. The BC of the auto transformers. So now here this is the 10 amps. Now what about this current here? This current. So how do we get here I2 current? So we know transformation ratio of the two winding transformer is equal to, so I1 by I2. So therefore I2 is equal to, so I1 into k times of this value. So I1 is a 10 into, so here is a N1, this is that I1, k you can write k is equal to N2 by N1. So now this is the 10 into N2 by N1 means 100 divided by 200. So is equal to 5 amps of the current. So here the how much amount of current flows? Okay, this is equal to 5 amps. Okay, I1 is equal to 5 amps, and we required this the load current. For example, this is the BC. So BC number of the turns. Okay, BC that here is a 20. Okay, 20, and this voltage is equal to how much voltage value here? 200, and this is a, let us find out voltage here, this value. Okay, voltage V2 is equal to, sorry, this is the V2 of two winding transformer. So that equal to how much? N2 by N1, the V1 of two winding transformer. So this is equal to N2 is 100 divided by 200 multiplied by 200. Okay, it is equal to the 100 volts. Okay, 100 volts. So now this value is equal to 100 volts. Okay, here 100 volts. Okay, it is a 100 volts. This was given. Okay, so when it is 100 volts, and here is this is a 200 upon 100 volts transformer. This is 100 volts, two winding transformers like. Yes, that's correct. I2 is equal to, so now here I2 is equal to how much? 20 amps. Here is a 100, and this the BC turns are given. but this number of the turns is equal to, suppose total is equal to here, so this is a total number of the turns. So it is equal to, we can write voltage initially 100 by 20. Okay, here this EHV is equal to VBA is equal to by 30. So now this value is equal to how much? EBA. Calculate EBA value. So now this is equal to 2 and it is a 100 by 300 by, it is a 150. So now it is a 100 and this one is a 150 volts. So if it is connected here 250, so now resistance is a 25. Sorry, 20 only. Have we calculated here this part? Okay, find this one. Okay, here we know this part. Here I1 is equal to IHV plus ILV. Already we know this. We know that I1 is equal to ILV plus IHV current. Okay, ILV plus IH. So now when these two are connected in the series R2 polarity nature. So now here ILV is equal to, so this value equal to, we got 5 amps, right? Okay, it is a 5 amp. I1 is equal to 5 amp. So now calculate here 120, 100 volts and 150 volts. So now this value is equal to 250 volts. So now here 15. Yes, finally what is the answer? That is a 20. If IT is equal to 20, then what about this current? Current in the BC section. Current in this BC section. Ten amps, okay, here, and we can calculate this 10 is equal to 5 amps. Current flows in the BC section here. Okay, this is the 5 amps of, here is the, here this the current is the, this value is equal to I1 is equal to 5 amps. So if we know this one, we can get I2 here. So this value is a required. So how do we get I2 value? So here number of tons is given. Tons here in this range, it is equal to, okay, this tons is a NBC here, NAB here, that is a 30 tons. Okay, 30. And this one is a, okay, NBA is equal to, it is a 30, right? And this is the NBC is equal to 20. So now these two windings are electrically isolated. This is the induction part and this one is the conduction part. So now that's why we can write, so here I1 by I2. Okay, this is I1 by 30. I1 by the 30 is equal to, just apply the ampere turns. Okay, ampere turns here. So I1 N1 is equal to and I2 and N2. So now from here we can write I2 is equal to, so this is the 5 and it is a 20 divided by 30. So here 30 is equal to, or 30 divided by 20, 50 into 20. No, it's not correct. Just I will wait some time. I will tell you this part. Yes. Okay, here input kVA of, okay, is equal to 1 minus k times of the induction kVA. Okay, induction kVA. So input kVA is a V1 and I1. 1 minus k times of the where I write in 5. Yes, actually it is a I2 is equal to, I1 is a 10, N2 is a 100, I2 by I1. Okay, it is written as a, that's correct. Yes, I have taken wrong. That's why I'm getting the wrong answer. Just wait. Yes. So it is a I1 current and we have to find out this I2 current. So how do we get this I2 current? First one, find out the transformation ratio ampere turns. The I1 N1 is equal to I2 N2, right? So this the transformation ratio is the same. So now it is equal to I2 is equal to, okay, here I2 is a required. So that is a I1 N1 divided by N2. So now it is equal to, I1 is a 10 amps, okay, N1 is equal to 200 divided by, okay, this is the 100, so that it is equal to 20 amps, okay, 20 amps, right? That's correct. So I have taken in the reverse, that's why I am getting the wrong answer. So this is the, we are getting I2 values, okay. So here it is a 20 amps, okay, 20 amps here. So now find out this current, okay, this is the 20 amps, voltage is a 20 amp. So now let us find out the voltage. So V1 by N1 is equal to V2 by N2. So we required V2. So V2 is equal to, so how much amount of the voltage V2? V2 value is equal to, V2 is a N2 divided by N1 multiplied by V1. Okay, N2 is equal to the 100 divided by 200 into 200. So now it is equal to 100 volts. So now this voltage is equal to 100. Okay, 100 volts. Okay, right? And now this is equal to how much? Here 150 volts. No, it is 100 volts, Nageshwar. This is 100 volts and current is a here. So now these two are electrically isolated, right? Electrically. And these two are electrically connected. So now we know input kVA here. The input kVA of auto transformer. Let us find input kVA of auto transformer. So that is equal to how much input kVA of auto transformer here? So V2 multiplied by I2 values. Okay, V2 is equal to 100 volts into 20. So now this is equal to 2 kVA. Okay, 2 kVA here. So now by using this turns ratio, okay, this is the number of turns and number of turns. Now find out here I2 value. So here we will get the 2 kVA. So we know that input kVA is equal to output kVA and induction kVA is equal to 1 minus k times of input kVA. Sorry, this is a, now number of tons here given 30 and this is the 30 number of the tons. Okay, these are 30 and number of tons, okay, here is a, okay, this is the, so that we can write directly. So here number of tons here 100 divided by, so this is the 30, no 20 here, so is equal to, so here we required, we don't know Vx, so that is the number of tons is equal to VAB here, that is a 20. So now this is the 20 and it is the 30. So now it is equal to how much? The Vx is equal to, we will get 150. So now here the 120 it is a 2 kVA. So here 2 divided by the 250. So now that's why here Vx is equal to 250. So now 250, 150 into, okay, calculate now, 2000 divided by, yeah, so this is the, okay, it is equal to 20 amps, current flows here, so this is the 8 amps. So now here if it is a 8 amps from, so this value is equal to 8, the remaining BC section here, so this is equal to, that is a 12 amps, okay, 12 amps. So from the, which one here you can get from the A to B, the 12 amps from the B2 to C outgoing terminal, then only will get here 20 amps. So option B is the correct. Okay. So now today I stop here. We will discuss the remaining part tomorrow. Almost I have completed 3 hours class today. Yes, that's correct. So, okay, I have completed almost all the problems based on the auto transformer. All possibility questions. Okay. All possibility questions. Okay. So, tomorrow we'll discuss all the problems based on the 3-phase transformers. Okay, complete the question series. Complete question series on 3-phase transformer. This part I will discuss tomorrow. Okay, don't forget. So, me complete ga 3-phase transformer lo ఏ క్వశ్చన్స్ అయితే ఉన్నావో అవే క్వశ్చన్స్ అగైన్ ఐ విల్ టేక్ 3 hours క్లాస్. సో కంప్లీట్ గా ఏ క్వశ్చన్స్ అన్ని క్వశ్చన్స్ నేను డిస్కస్ చేస్తాను. How was the class today? I hope you are doing well and you enjoyed a lot. So this is official Creatrix channel which has 150k plus members. Okay, and if you want any updates from the Creatrix, join in this channel. And it is Unacademy GATE Telugu channel. మీరు ఏ క్లాస్ నోట్స్ కూడా క్లాస్ అప్డేట్స్ కానీ క్లాస్ నోట్స్ కానీ అనౌన్స్మెంట్స్ కానీ సో ఈ అన్అకాడమీ గేట్ తెలుగు ఛానల్లో మేము పోస్ట్ చేస్తాం. సో ఇఫ్ యూ వాంట్ ఎనీ అప్డేట్స్ ఫ్రమ్ ది ఛానల్, సో ప్లీజ్ జాయిన్ ఇన్ దిస్ ఛానల్. Okay, these are the different type of channels under the Unacademy. So one is the Creatrix Gate, Unacademy Gate Mechanical, Unacademy Gate Civil, Unacademy Gate Telugu, Unacademy SSC JE, okay, Unacademy Computer Science, Unacademy Gate Questions, Electrical Junction, Unacademy Engineering Foundation, Engineering Pathshala. Thank you all. Thank you very much. Okay, if you have any doubts, please message me. I will answer that.